Good morning, Kishore sir.
Morning,
Narang sir,
morning.
Bharat here.
Hanji Bharatji, how are you, Dr. Bharat?
I'm fine, sir. How are you, sir?
Very fine, thank you.
Sir, just waiting for some participants to join
No
because
problem. Take
no
your
one
time.
is punctual like you.
No, no,
So,
it's perfectly all right. It's perfectly all right.
yeah.
Yeah,
Thank you, sir.
thank you. Welcome.
It's 10 hours.
Good morning. Good morning, resource person, coordinators, and dear participant. On behalf of E&ICT Academy at IIT Guwahati and NIT Patna, we welcome you all for the day 9 session. Today we are having the session for Mr. N. Kishore Narang on building the competence to innovate IoT and its disruptive technologies. So with this, I may request Naran sir on behalf of E&ICT Academy, IIT Guwahati and NIT Patna to please start with the session. So please, sir.
Sure, thank you. Good morning to one and all. And I'm not sure how many people attended my first session, but I think I'll have to continue from there on. I'll presume that Most of you people attended the last my talk on the 27th of July. Okay, and we'll start from there. So I think today we'll have some deep dive into some communication related topics. And the first one that I'm talking about is Unified and Secure Last Mile Communication Protocol Stack Architecture Standard. Okay, and so what is the motivation? What it is all about? And so let me give you a little background, which I talked about in the last talk also. So what we have today, I'll give you a scenario of a smart cities. In a smart city, you have all the smart solutions deployed, 15 to 20 different smart solutions, smart services being offered to the citizens. And for that, what is happening? Whether it is smart meters, smart water, smart gas, smart traffic lights, smart environment sensors, smart street lights, all these smart solutions, they need ICT network and infrastructure. And what is happening right now? All the different vendors, different solution providers, uh, deploy their individual communication networks along with the IT infrastructure also to deliver these smart services, smart solutions, and all, smart infrastructure. And so, what is the result? Result is that uh, in the same geographical territory of any particular city, we have 15, 20 different communication networks working simultaneously to deliver the services to the same set of clients, which are the citizens and the government and institutions. Does it make sense? So about 10 years back, we started looking at this problem, and we realized that if the geographical area is well defined, why can't we have one common unified ICT infrastructure end to end, common thing, which all the service provider, all the utilities, and all the different services, they leverage that common ICT infrastructure. What it will deliver is basically it will deliver your thing, your all the services at a very low capital expenditure, very low operational expenditure, and it will also reduce the carbon footprint of the ICT infrastructure being deployed left, right, and center. And last but not the least, it will also deliver is, since it is a well architected, unified one infrastructure, it will be much easier to make it secure and resilient. Because we know where what is going, but when we have multiple infrastructures deployed by different vendors and with different solutions, we do not know where is the vulnerability can hack in. The attack surface area is not really known, and it increases many folds. So for those kind of motivations, what we thought that let us have some kind of a unified architecture. And when we say unified ICT architecture, you all know that at cloud integration is very, very easy, relatively. I'm talking. But when it comes to the field networks, the communication networks, there's a whole, it's a different challenge altogether. There are multiple reasons for that. And what is that? Is that the one other thing is that every use case needs a different kind of communication technology based on the deployment scenario. And how do they different technologies, different communication technologies, work together? Okay, so what we realized when we did some study and analysis is that so this is the complete this is the complete silos that I just talked about, and then this is the kind of unified architecture that we are looking at going forward in our smart cities, and we are already in the advanced stage of developing standards. So this unified ICT architecture has been developed. Now we have also developed the unified last mile communication protocol stack architecture, and we'll be talking more into the last mile communication. So, so what we have realized is that in the last mile, and end sensor connectivity is very heterogeneous, and a good candidate for evaluating the needs for a unified communication stack is this particular problem, that how do we work. So what we decided, we thought let's look at different communication technologies, and the first one that we already have developed some kind of you can say advanced level of standards already, and more or less finalization stage, are constrained RF network for control and monitoring, non-streaming signals in sub-gigahertz band. So you already know that there's an unlicensed band of 865 to 867 megahertz, where the spectrum is still being, further enhanced. But even in this spectrum is quite conducive to for higher penetration. Whether there are few million energy meters street light deployed, but right now there's no unified stack even for the 8. Everybody says it is 802.15 IEEE 802.15.4 stack, but your stack from my stack does not interoperate. Okay, so how do we work on that? So that was one of the another problem that we looked at. So what we did was we tried to identify this thing, different communication technologies, which will be deployed in the smart infrastructure networks in a city, okay, or any other for that matter. City is not important. City, village, district, state, or even the nationwide. This architecture is completely scalable. Okay, so what we realize is that we need a I'll straight away, I think I'll not get into this. Let me show you a very simple diagram. Yeah, so this is a very simple diagram that you are all used to. I hope you have all seen this OSI reference model. Okay, so what does it comprise of? Physical layer, data link layer, network layer, transport layer, and then we have session, presentation, and application, which are also collapsed into one common this thing. L5, L6, L7 are even collapsed into one common application layer also at times. Okay, but what is interesting to see, network and transport layer, when we talk about the IP regime, the stacks, these layers do not change really, if you really ask me. But what changes with each and every communication technology is the PHY and MAC, the L1 and L2. And we realize that, and since you all know that PHY and MAC, the data link layer, for L1, L2, they are very closely bound. The moment you change the communication technology, your PHY changes, the MAC also has to be accordingly adopted to suit that particular communication technology. So what we realize that in a given scenario, we could, okay, let me just talk with, first of all, diagram, then we'll come back. Okay, so this is a typical, you can say, thing. So what we realize that this, upper layers, right, from network, transport, session, presentation, and application, can be standardized. Okay, and if we just introduce another intermediate network access interface layer, okay, you can see the third layer from the bottom, then I can, what I can do, I can actually change my different communication technology and their communication, their MAC and PHY, and make this network access interface layer as a interworking layer to interface it with a unified standardized L3 to L7 stack. So this was the basic thought behind the whole concept and the whole set of standards, and we realized that this is very much possible. And what we did was, so this is the overarching, you can say, block level architecture. So we have a network access layer, okay, which basically comprises of PHY and MAC layer. Then we have network access interface layer. Then we have network layer, transport layer, application layer. As I told you, it is a collapsed application layer using all the, combining all the L5, 6, 7, and then security, as you know, it is cross-cutting. And we also realize that network access interface layer also at times, based on communication technology, has some kind of a we can say relevance or interworking with the transport and network layer. That's why you see the network access interface layer as an L-shape, even covering transport and network layer. Okay, so how do we take it forward? So let's take one particular technology. This is a 802.15.4, very well known as IEEE standard. Okay, and we already have 802.15.4U, which is harmonized for Indian spectrum, your D-license band. Okay, and now if I need to interface it with my upper layer, what do we have in the network access interface layer? We need a 6LoWPAN for IPv header compression. Then we have RPL. Then we have 802.15.9 and all other these things. So this particular set of these individual standards, IETF RFCs and other thing, they help us bridge our this particular PHY and MAC combination with the upper standardized network, transport, and application layer. And the security, you can see it is also going into the network access interface layer. That means security will have complete surpassing or you can say interworking with all the layers, because we need a comprehensive security. PHY and MAC, they have their own security standards and protocol based on the kind of MAC we are writing, the kind of PHY we are using. Okay, so let's look at it for the Wi-Fi. Now you see the network access layer has gone from 802.15.4 to 802.11. Whether it is 2.4 gigahertz, 5 gigahertz, or even sub gigahertz, we are going to have Wi-Fi in the sub gigahertz mode band also. So what we do, we just change the network access interface layer to make it compatible to the upper same this thing. So what do we have in the transport and network layer? In network layer, we have IPv6, ICV, MP, this thing, and transport layer, we have UDP, TCP, DSCP, and all such ITF RFCs. And if you look at this, you can see the L3, L4 remains the same. Even the L5, the upper application layer. You can see again, nothing has changed on the upper layers. Simply by updating the network access interface layer to match the requirements of the particular communication technologies, the corresponding MAC and PHY, we can make the upper layers standardized and seamlessly work with different communication technology. So this is a total amalgamation of different technologies, okay, where you can have MAC and PHY of different technology. You can see that from left we have 802.15.4, then 802.11 Wi-Fi, and then even NBPLC, narrowband PLC OFDM, and 1901.2 IEEE. Again 802.3 Ethernet UTP wired. Then you can have even the cellular 2G, 3G, LTE, 5G. We can even have the Wi-Fi 6, which we are talking. So any particular technology, you see the all last mile communication technologies we can use there, and with simply modifying the network access interface layer, my upper stack can be standardized. And you'll say, why? What does it add? How does it add any value? So if you see the interoperability, when we talk about, it is all about syntactic, semantic, and all that. So application layer plays a major role in that. Okay, and application layer is where so I will go into details into application layer also. So if you see, this is the kind of overall stack that is going to look like. So this is say a tentative figure. You can see. So communication network layer actually covers right up to the L3, L4 also, because we have the network and transport. So you can see different PHYs and MAC are there. Okay, and then we have the network and transport layers. And then comes the application. You can take a look at the application layer. What do we have? Okay, we have data format, serialization, messaging, protocol, security, and in that there are multiple, use cases. So right now, what we have for smart metering use case, the application layer is very well standardized, and it is being used in all the smart metering deployment across the country. But if you look at it, the smart city use cases, we find these new standards are more relevant for data formatting, SNML, which is the ITF RFCs, 8428, public TLB, CBOR, RFC 7049, text, JSON. There are multiple serialization technologies. Then for messaging, we have lightweight M2M, which is a device management standard also. And for protocol, we are using CoAP. We can use HTTP, MQTT. At the security level, we can have OSCORE, or we can have HTTPS or MQTTS. Now, these are the things that we are still at the final stage of freezing. So what to standardize as for once and for all to make the whole even application layer absolutely interoperable. So let's go one by one. So you can see what does network access layer talk about. So it consists of a set of tightly coupled PHY and MAC layer definitions, functions, and characteristics. A PHY layer contains the definition, functions and characteristics of physical layer being used. The physical layer may use a wired wireless communication technology. And for reference, I've already shown you the figure diagram. Then medium access layer control layer. This block of reference architecture contains the definitions, functions, and characteristics of medium access control layer being used. The MAC layer, based on the physical layer, may use a wired or wireless communication technology. For reference, it has been illustrated how this reference block shall be realized in the actual standard. You have shown in the previous this thing. So now what is this? This is a real new innovation. In fact, if you really ask me, I could have patented lot of approaches which we used and developed rather, okay, for developing this network access layer architecture. But we chose to not to patent them, but to use it for national standard, keeping them open. Also, innovation can be leveraged anywhere, as you know. So this block of reference architecture shall comprise of either existing open standards or newly developed different glue logics, algorithms, interworking mechanisms, and or methodologies, or a combination thereof, required to seamlessly integrate the lower MAC and PHY layers with upper layers, network, transport, and application of the stack. For every different communication technology, deploying different network access layer, a separate set of network access layer specifications shall be developed, comprising of unique combination of open standards and or newly developed glue logics, algorithms, interworking, what I mentioned again up in this thing, corresponding network access layer of the respective communication technology with standardized up. For reference, it has been illustrated how this reference block will be realized in the actual standards in figure 1, which I showed that for the 802.15.4 MAC5, we use 6LoWPAN, RPL, and other standards to leverage this MAC and PHY and make it standardized with the upper layers of the unified communications protocol stack architecture. So network and transport layer, these are very well common this thing, and since we are right now talking about only IP, so all the standardized mechanism like IPv6, ICMPv6, UDP, TCP, DHCPv6, and other existing standards are used. Okay. So the objective is to create a unified network and transport layer, which can be used seamlessly with different underlying lower layer at PHY and MAC and application layer on the top. So what is the application layer? I think I've already explained you, but let's go through once again. The UDI, we call it Unified Digital Infrastructure. LMCPS is Last Mile Communication Protocol Stack. Okay. Application layer consists of a tightly coupled set of definitions, functions, and characteristics. Application layer comprises of communication protocols and interface methods used in process-to-process communication across an internet protocol computer network. Application layer only standardizes the payload frames and interworking between different end nodes at the application level. The communication depends on the underlying transport layer protocols to establish host-to-host data transfer channels and manage data exchange in a client-server or peer-to-peer networking model. Though the TCP/IP application layer does not describe specific rules or data formats that applications must consider when communicating, the original specification, the RFC 1123, does rely on and recommend the robustness principle of application design. So what is the scope of application layer? This application layer definition is purely applicable for devices operating in the last mile constrained networks of the nation's smart infrastructure. Devices that you can consider in scope are constrained and ultra constrained devices, few kilobytes in RAM and storage, devices that may have sensors that sense, measure, and some metering and or control application, devices that have IPv6 connectivity. And in this particular stack architecture, non-IPv6 devices are not in the scope. Okay, operations in the scope, managing, controlling of such devices, changing parameters on the devices, remotely updating firmware on the devices, and identifying the ownership. So the important functions of the application layer, and application layer encompasses the business logic, the functional behavior implemented through programming, along with the procedures related to the device under question, the likes of remote device management, security, transport layer, protocol support, etc. And you see that all the kind of basic 5 blocks that we are talking. There we go into the construction of the complete application layer standard. So individual role of each package is like payload carriage. It needs to have ability to handle data, volume, variety, and velocity required for constrained application run on constrained network. We are not considering any streaming application, so please do not confuse it with the video surveillance and all that. For that, those kind of application, this architecture or this particular standard is not valid. Okay, support required data frame sizes for various use cases in scope, support for both request response and publish subscribe communication models, web-oriented support paradigm, provide non-compromising device management functional scope extensible to new device management function of the future, ability to adopt to transport layer protocols commonly used in the internet support, possess construct for reliable communication transfer, bring inherent security to protect data frames irrespective of network security. So these are the basic, you can say, the core characteristics that are required in the application layer to make it seamlessly, scalable, valid for tomorrow's smart digital infrastructure or critical infrastructure that we're talking. So, there's a list of so many different protocols that we have been able to identify the whole metrics of that. I'll be sharing this slide deck so you can go through it at peace and understand. And if you have any question, you can always revert back to me one-to-one also. So these are some of the core characteristics that we are looking at from the protocols for the application layer. Okay, so efficient transport, distribution overhead, reliability, security, RESTful, near real-time support, blob transfer, payload agnostic, multiple transport profiles, support for communication, common communication models. So out of these, we identified different things, and based on the merits of each protocol and with the corresponding requirement, but then we are right now in the process of finalizing the complete package of, or you can just different IETF RFCs and standard that we'll use to, constitute our application layer. So, when we talk about interoperability, why we standardize, as you all know, basically standardization is for bringing interoperability into the any system solution, and last but not the least, most critical part of the devices of the whole thing is devices, because everybody designs device in one's own way and they implement protocol their own way. If you look at the startup ecosystem, every startup thinks they are the most innovative people and they will do their own protocol. Does it really make any sense? It does not, because then their devices cannot interoperate with anybody else's devices, and they cannot offer those devices into the common infrastructures of the nation. So, in fact, their so-called innovation is actually blocks their proliferation into the business. So, but when you talk about device interoperability, there are 3 different options that can be used. Option 1 is integrating at the backend system. Okay, you use your own device, you use your own gateway, and take it to the cloud, and then you try to integrate and write some common information models, interworking proxies, and all that, and you come. Okay, second option is integrating at the gateway level. You may have heterogeneous devices in the field, but then at the gateway level, you convert all the protocols. You have all different communication modules corresponding to each particular protocol, each particular standard, this thing that people have used, and then try to bring all the integration and interoperability at the gateway level. The third is common device protocol. So what we are trying to do is develop a common device protocol. Common application layer and device data semantics also need to be defined. Okay, currently there is no universal protocol, and domain-specific protocols are prevalent. So the problem is option 1 and 2 can be used for non-IP based communication or domain where normative standards are already defined and are in practice, or even legacy infrastructure. You would say when we have this new standard, okay, future deployments can be based on these standards. But what about the legacy infrastructure, which has already done multi-billion-dollar infrastructure in different cities, different states? How do we integrate? So for the legacy infrastructure and non-standardized or proprietary protocol-based infrastructure like LoRa, Sigfox, and all these different solutions that have been already deployed in the industry, in the field, for them, option one is the only way out. Okay, but coming to the this thing, when you talk about option two, integration at the gateway level becomes very, very complex. Okay, because the gateway, each gateway will have to, based on the kind of technology that have been deployed, will have to have so many communication modules within it, and then protocols. All the interworking proxies will have to be written, designed, developed at the gateway level, which will become a nightmare because there's a heterogeneity of the devices. So option three is the one which we have recommended, and what we say is that, and what is the advantage we get here now? Once this standardized last mile protocol stack is developed and standardized, now all the devices, irrespective of which communication technology they are using, they are all spread over the city. For example, we have a crossing in a city. I put a standardized gateway, okay, with a few communication modules based on the communication technology where L1, L2 are different, and L3 onwards, the stack is standardized. Now, what is the advantage? All different devices belonging to different verticals, use cases like smart street lights, smart traffic lights, smart environment sensor, smart dustbins, smart water meter, electricity meters, all those within the range of the gateway and its communication technology based on which it is being particular devices are used. They can use the same common standardized gateway to communicate with the cloud-based, system software platform. So this way, we really optimize on the infrastructure cost. So what we need is in the city, whole city wide, we just have one common mesh network of the gateways, which have multiple option of the standardized technologies like cellular, Wi-Fi, sub-gigahertz, and maybe PLC also. Whatever standardized IP-based technologies are there, and we can now have a seamless communication of all the standardized devices with the cloud without any hitch. Okay, so I was talking about this is a typical, device application layer background. So how do we use it? So on the right hand side, you see the basic 4 layer, which I talked earlier in the slide: data encoding, data modeling, data semantic, messaging, and application protocol. Okay. Now this is the blow up from the overall. You can say on the left hand side, you see the overall stack. So the application layer and all this has been now, blown up, or you can say magnified and zoomed up, and gets into these basic 4 layers. So security, that is another very interesting but very critical aspect. Security block or layer consists of a tightly coupled set of definitions, functions, and characteristics for comprehensive and intrinsic security in the unified protocol stack reference architecture. It comprises of a set of security standards to be used to address the security requirement of the stack comprehensively. The chosen standards may be used at different layers of the stack depending on their context. This block may need to be defined differently based on the technology being used at MAC and file layer. However, some different communication technologies may use a security block common to some other communication technologies as well. So this will have little bit variations, but not too many variations based on the communication technology. So I think before I go to the 5G, let me just wrap up this particular thing. What are we trying to do? So what we have discussed right now is that we are looking at this unified communication stack architecture, okay, for the last mile, where we have standardized our L3 to L7 stack into common this thing, and we have the network access interface layer introduced in between to interwork between different FIs and MACs of different communication technologies. And as I mentioned, security will mildly vary, but more or less things are being standardized now. So, and one thing you must note that in this whole stack architecture, we have not done any new or any proprietary standard or innovation. Our innovation is in the glue logic. Okay, how do we standardize this? So it's something like, you prepare a biryani. You have a Hyderabadi biryani, you have Mughlai biryani, you have a Punjabi biryani, and you have all that. What do they do? What is the difference? It tastes different because the recipe is different. It's all biryani. It's all pulao. It's everything the same. So what we have done is we have just standardized the recipe of how each layer will be constructed using different open standards, whether ITF-RFC is IEEE, IC, ISO, ITU standard. So we have not done any rocket science. It's just an innovative thinking to address the gap or in interoperability with a very simple logical thinking. And so this is the kind of innovation that industry needs, the society needs. So the question is, are our researchers, our engineers and masters and PhD, are they looking at some such problem, some industry related problem, some applied research are they doing, or they are only doing something, studying 10, 15, 20 papers, deriving something, maybe some incremental, theoretical, hypothetical, some research, some achievement, which may not even go down in the field. Any research, any innovation that does not get applied in the used by the society, industry, and business, I don't think the researcher or innovator gets any gratification out of that. So I think that is one of the core things that we need to keep in mind whenever we are looking at any new research or innovation opportunities. That how do we, identify our problem? What kind of problems we look at? Okay, skill sets can all be acquired. Okay, I'll tell you what. I did my engineering in '77 when none of these technologies were there. Okay, and I left my last job in '81. Since then, I've been running this small independent design house. How I have updated my knowledge? If you're dedicated, you are interested, you can always upgrade your skills anytime. And it's in today's technology world, it's a continuously learning time. If you want to be in research, design, education, you have to always stay ahead of your time. You have to stay updated with the latest technologies or even the cutting edge technologies. Have a peek into the future. What are the technologies which are going to be coming in next few years, a decade, or whatever? So when coming to the futuristic technologies or disruptive technology, one of the most disruptive technology that is on the horizon already is, as you know, which one? 5G. So let's start. So when you're doing all this work for the smart city standardization, the common unified ICT infrastructure, last mile communication, we also realize that we are already standardizing a few standards for interoperability to achieve a comprehensive, interoperability in the smart city and smart infrastructure. Now, what will happen when this 5G comes? All the 5G proponents will come rushing to all the smart city people that look, now we have got a new technology, is very good. It will deliver you this, it will deliver you that. Why don't you rip off this old infrastructure and deploy 5G? That will totally disrupt the business as usual in the country. And particularly, India is a financially constrained nation. Now, how do we make sure that as and when 5G comes, whether 2 years later or 5 years later, let's not get into that. 5G has a smooth migration path into the smart infrastructure and smart cities without disrupting any of the existing infrastructures, technologies, and standards. So that was the thought process with which we thought now it will be very important to understand what 5G has got all about, what it is all about, and what new things it brings in, and how we can have a smooth, seamless migration path in embracing 5G as and when it is commercially viable to integrate and deploy in our smart cities and smart infrastructure applications. So with that, we started studying the 5G, and what we realized, these are some of the enabling technologies and paradigms. Virtualization is one of the core things. IMS, SDN orchestration, evolved packet core, machine learning, robotics-based closed loop self-healing, network slicing on transport and core layers. Then ultra-high storage and compute is a very critical part of the 5G. We are looking at very big data stack with all the networks, customers, performance, and crowdsourced data. Already, IoT use cases are ready for implementation in 5G domain. So these are some of the domains that even 5G is looking at. Why? I'll come to that in the next few slides. That we have ultra reliable, low latency communication, and then we have massive, machine type communication also as part of the 5G. And these are some of the, low power, wide area IoT connectivity technologies and, their use cases, applications, and all that. So we are reaching already. So the 5G level. So when we say 5G and IoT, they both are going to play a crucial role in our smart city, smart infrastructure for this thing. And as I also mentioned, these are slides from my last talk. Also, some people who attended might find them repetition, but I thought it is important to maintain the continuity of discussion. Okay, so IoT may require differentiated service levels. Why? Because IoT covers a large range of applications, and it can be machine to machine or consumer or healthcare or automotive. These applications will have varying degrees of requirements for connectivity as well as data transmission. While a healthcare device may collect continuous amount of data, or a smart appliance may not have to be transmitting continuously. You can even consider with an automobile, for an example, various systems, all systems related to safety may need continuous monitoring and real-time feedback. However, an infotainment system may have different requirements. Environmental applications such as clean air and water monitoring system may have another set of requirements. All these applications will transfer varying degrees of data, some large, some small, and others will be mix of these at various intervals, or versus something will be real time also. It may be important to understand that these requirements from a systems perspective and offer differentiated class of services within a network that provides connectivity. So the interesting part that is coming up is differentiated class of services within a common network for different services. How do we do that? Okay. And you're seeing technologies have always been in there to support the business evolution. Okay. They have been, whether we talk about broadband and media, intelligent traffic system, mining, remote healthcare, like in 2G, 3G, this thing, ARA, we had this level one of the, you can features in the domain. Now, when we go to the 5G and virtualization, we have some further optimization, some further throughput in the same very applications. And going to new radio RAN virtualization, we will have further performance improvement as well as optimization. Okay, and so all these, different set of you can say verticals and horizontals, they have evolved as the technologies have evolved, and their performance, their throughput, their optimization, their energy consumption, their radio this thing, wave propagation quality, spectrum efficiency in the utilization. All those characteristics have been changing with the evolving technologies, and they're always on the improvement only. Okay. So this is a snapshot of the 5G wide requirement, and this is a very famous diagram you must have seen. So what is 5G all about in a nutshell? It is about three main paradigms. One is the enhanced mobile broadband. So you have a video download in a few seconds, and all those kind of features are part of enhanced mobile broadband. And you can say like a stadium experience, multiple this thing, billion mobiles downloads on the same streaming service. All those are basically and these are the set of use cases that will be enabled in the first phase of 5G deployment. So earlier that, first of all, the first flavor of 5G that consumers, citizens will experience is the enhanced mobile broadband. Okay. And second is the massive Internet of Things that we just discussed. And third, last but not the least, is mission critical control, that is ultra reliable, low latency communication, which can be used for remote diagnostic, remote operation, remote surgery, robotics, and all that kind of applications. So how do we, when we move from 4G to 5G, what kind of changes can we expect, or what is like? So major difference from user point of view between 4G and 5G must be something other than faster speed. Because normally people look at migration from one generation of cellular to another as a only speed. But here we are looking at something much beyond that, like higher number of simultaneously connected devices, higher system spectral efficiency, means data volume per area unit, low battery consumption, lower outage probability, better coverage, high bit rates in larger portions of the coverage area, or lower latencies, higher number of supported devices, lower infrastructure deployment cost, higher versatility and scalability, or higher reliability of communication. These are some of the things people are looking at from when we move from 4G to 5G. So 5G in smart infrastructure to support the main vertical sectors, namely automotive, transportation, healthcare, energy, manufacturing, and media entertainment. The most important 5G infrastructure performance requirements are a latency below 5 milliseconds, support for devices densities of up to 100 devices per meter square. Just make note of this. This is really dense. Reliable coverage area. Okay, and so a successful 5G deployment will integrate telecommunication technologies, including mobile, fixed, optical, and satellite, both GEO's set of satellites and MEO's set of satellites. And what are now further expectations from 5G? Data rates of tens of megabits per second should be supported for tens of thousands of users. So right now you must have seen when there are so many people consuming a lot of bandwidth, your individual bandwidth download speed goes down. Here we are looking at tens of megabits per second for tens of thousands of users simultaneously from the same network in the same geographical location. 1 gigabit per second to be offered simultaneously to many workers on the same office floor. Several hundreds of thousands of simultaneous connections to be supported for massive sensor deployments. Spectral efficiency should be significantly enhanced compared to 4G, which I have already mentioned. Coverage should be really very improved, like we have today, so dropouts and all that, drop calls, nothing should happen, or fading out. Even in our virtual meetings we have seen, we start losing video, we start losing audio simply because of what bandwidth constraints, which keeps on fluctuating. So we cannot afford to have that in future also. Signaling efficiency has to be enhanced. Latency should be reduced significantly compared to the current LTE. So how do we summarize? So what people are looking from 5G is a super efficient mobile network that delivers a better performing network for lower investment cost. It addresses the mobile network operators' pressing need to see the unit cost of data transport falling at roughly the same rate as the volume of data demand is rising. It would be a leap forward in efficiency based on the IIT demand attentive network philosophy. So we talked about super efficient mobile network. Now we are talking about super fast mobile network, okay, comprising of the next generation of small cells densely clustered to give a continuous coverage over the last urban areas and getting the world to the final frontier of true wide area mobility. It would require access to spectrum under 4 gigahertz, perhaps via the world's first global implementation of dynamic spectrum access. So this is a super fast mobile network. And then we have, last but not the least, a converged fiber wireless network that uses the first time for wireless internet access, the millimeter wave 20 to 60 gigahertz, so as to allow very wide bandwidth radio channels able to support data access speeds of up to 10 gigabits per second. The connection essentially comprises short wireless links on the end of a local fiber optic cable. It would be more of a nomadic service like Wi-Fi rather than a wide area mobile service. So within 5G, you see, you have two different sets of services. One like a outdoor kind of the 5G, which will be under 4 gigahertz band, and another between 20 to 60 gigahertz. This will be more like a Wi-Fi. for the local thing like a Wi-Fi kind of thing. So what we are trying to do to make it seamless, integration or embracing of 5G into the smart infrastructure or IoT technologies or infrastructure which are deployed when it comes. So what we are trying to do is we are trying to identify 5G friendly, 5G intensive, and 5G extensive applications and use cases within the smart infrastructure paradigm and even outside. So because see, every use case has its own set of requirements. So we need to identify which will really improve their performance when 5G comes, or which are not possible today because 5G is not there, and which can be okay. So there will be some use cases which do not need migration to 5G. They are very happy with 2G, 3G, 4G networks. There will be some use cases who are already working reasonably okay, but their performance will improve if we have 5G. And there will be some set of use cases which are not possible today, but only when the 5G comes, then they'll become possible. So we need to classify, categorize these kind of use cases to make sure where 5G will be more relevant. Then identify the feasibility of developing application layer standards around them. I'll come in a moment about what it is all about, what I'm talking about application layer standards. Develop a phased implementation and deployment plan for them. Develop the most optimized 5G inclusive ICT reference architecture for smart infrastructure. Develop a smooth migration and adaptation strategy from contemporary ICT architectures to the 5G inclusive architectures. So what we are trying to do for that is study the SBA, the service-based architecture, open APIs at 3GPP versus common service layer platform for use cases, and we are examining the APIs. How to leverage network slicing, service-based architecture 5G to implement diverse critical use cases and end-to-end quality of service mapping from transport layer to application layer. Role of virtualization, SDN, Mac, mobile edge computing, software-defined networks, for the dynamic use cases, implementation and deployment flexibility. So, so let me give you a background before I go to this. So I talked about identifying the feasibility of developing application layer standards around them. So let's go back in the history. If you see the communication till now, when we talk about ICT, means information and communication technologies, and today they have converged. Earlier they were working in silos. Okay, it was like in the field you have a devices, then you have a long pipe going to the cloud or to the IP platforms, and so the people who used to design, develop, work in these domains were also entirely different. Today, infrastructures have converged, technologies have converged, so now the skill sets also need to converge. The competencies also are converging. Okay, so what is happening is all the communication, the telecom, which used to considered as a dumb pipe, only to you used to transmit the transport the data from one end to the other, is now has become rather very intelligent. It has been softwareized. There's a whole lot of softwareization in the communication. How? If you talk about virtualization, you talk about containers, you talk about DevOps, you talk about agile. These are all the IT domain skill set technologies that were developed for improving the software platforms, performance, and making the different or even the infrastructure. Virtualization came so that we do not need customized infrastructure for different kind of applications. You have one common underlying infrastructure. On that, you virtualize different kind of a different machine, virtualization machine. You have all kind of different kind of individual OS applications, platforms, everything running individually on the same hardware through virtualization. But this was in data center, it was happening. Now it has gone to the telecom also. So all these virtualization, network slicing, this is all learning from the IT world, the software world, which is being deployed. So software-defined networks. Okay, network function virtualization. These are all, you can see the real amalgamation of communication and IT or software technologies. Okay, so with this, what is happening now? It's very easy to talk about 5G use cases in smart cities, smart infrastructures, health, automotive, what all. But how do we actually get down to that? And we, everybody from the 5G domain experts, they always, claim, oh no, 5G will, solve you any problem. It is so flexible. You can have networks, you can have configured each network slice for each service. It's easier said than done. How it gets done? The people who work in the application domains, they are the pure software people. They are not the communication people. Till now, they were content by only using their software skills. But now, how do they learn the network slicing and virtualization and all those things? How do they leverage the the power, the flexibility, the new features that 5G paradigm brings to the communication domain? That is the real challenge. So what we realize that how do we make this 5G network infrastructure very friendly to the IT people or the software people? Now, this is where we talk about application layer standards. So what we are looking at actually is that we have a 5G core infrastructure or architecture of the thing, which may be like this or any other. There are multiple ways of representing them. Okay, so what we do is on top of the 5G this core architecture, we build an interface platform layer or platform, which basically gives a use, you can say, gives you all the flexibilities to configure the core 5G architecture or infrastructure, which a normal IT good software person can do without actually getting into the actual 5G network, but being able to create his own slices, create his own, specialized services, quality of services, whatever they want to define. So we are trying to build a platform between, which will work as an interface between the telecom guys and the IT guys, means the telecom domain expert. And see, telecom is today, because of all the cyber hacks and threats and all that, the security is also very critical. The telecom operators or the people who are, or the organization who are running the 5G core infrastructure would not like novices from the software field to tamper with their infrastructure. So that is why we need a secure, isolated, but still flexible access to the configurability of the 5G infrastructures, all the vast features that it brings to the table. Otherwise, the 5G use cases will be always in the discussions and talks and seminars. They will not see the light of the day. So these are some glimpses into the 5G, architectures. I'm not going into details of these because this itself will take under 5 hours of class on 5G architectures and what it brings in. But just a quick look on what all does it entail. So you see here, there's a microservice architecture within the 5G. Okay. So, and cloud native application stack for 5G. This is a simple typical something which even the software guys are very, very used to. Now the communication and IT are merging. Then spectrum strategy is one of the very, very critical things. So we have different kind of use cases and deployment scenarios. But how do we look at the coverage, capacity, as well as the latency? So this the simple diagram shows you the interrelation and dependence of these three core characteristics, where coverage, how it moves from low band to high band, capacity, how it moves again from high to low or moderate to the at the lower band, and then latency, how the latency can improve as you go in the higher frequency bands. So this is very, and okay, whether, so what you do there, so like on the higher bands, high capacity, hotspot, dense urban application, they are very, very apt for that. But when it comes to low bands, we are even looking at like sub-gigahertz band for 5G. So moderate capacity, wide area, even outside the area coverage, they will be done by that. So the ability to handle multiple tailored use cases is what makes 5G more disruptive than previous generation cellular technology. As 5G will need to coexist and interwork with 4G for many years to come, we are likely to see vast majority of these deployments as non-standalone initially as a way of reducing time to market and ensuring. Yeah. So there's another fight going on in the 5G lobbies. There are two different lobbies. One is that so 5G also brings in a new radio, new different kinds of modulation. Okay, so there are different you can set of people who are in favor of deploying 5G new radio from the beginning. But the 5G also is you can say migration, or you can say improvement of the capacity in the 4G level of radios, LTE and advanced LTE and evolved packet core is all they were all available in 4G also. A lot of virtualization, all those features were also available in 4G. So what we are looking at is for next quite some time, it will not be a standalone 5G network, but they will have to interwork and coexist with 4G network and with the enhanced features that 5G brings in. Okay, so there'll be both kind of this thing, and there'll be graduation to the core new 5G radio and standalone. This thing 5G networks will still quite far away, to be honest. Okay. Current network architectures need to evolve to meet the needs of the wide variety of use cases enabled by 5G technology. As part of this, transport network also must evolve and scale efficiently to meet widely varying but strict requirements for performance, capacity, latency, and security. It must also support the various needs of parallel network architectures and technologies, and seamlessly support the coordination between many more cell sites, including those that will coexist with 4G technologies for many years to come. So what are the design principles for the 5G architecture? That's the kind of, so it is a agnosticism. It has to be agnostic of different technologies coming in. A microservice-based architecture. It has to have application resilience, state-optimized design, orchestration and automation have to be core part of it. Internal automation and orchestration and network level orchestration and automation both are integral part of the you can say design principle for a good 5G architecture. So what are the key attributes or paradigms which I already talked a little bit, but here they are properly listed that 5G paradigm brings. So distributed architecture, network slicing, CUPS, control and user plane separation. CUPS is control and user plane separation. Cloud RAN, radio access network will go in the cloud. So virtual network functions on cloud native digital services, microservice architecture, which I already mentioned, continuously evolving software and DevOps. Okay. So today, one of the main concerns about virtualizing the network function is backward compatibility. It is critical to make sure that virtual network functions can interoperate with the physical network functions and the older infrastructure. But even more important is how best to develop, test, deploy, and manage applications to take advantage of the new capabilities provided by 5G paradigm with all its key attributes. So when we talk about application layer, ALS is application layer standards. What are we going to standardize? The application platforms for different use cases, or interfaces with application layer with the other 5G network layers, and or whatever we choose to standardize, how granular we want to or we should go. These are some questions which we are right now trying to understand and answer before we actually get down to application layer standard development. So what are the thoughts for the immediate next steps? We are going to follow a comprehensive system approach, I think, which I talked about in my last talk. Study and analyze the selected use cases to understand their respective characteristics. Study and analyze the 5G network architectures and enumerate their characteristics as well. Then develop a matrix to map the applications or use cases characteristics with a 5G network architecture characteristics that shall enable and empower the applications characteristics. So once we have this mapping, what will it give us? This mapping shall help us understand and develop customized 5G architectural views that shall meet any single or set of applications or use cases. This shall also help us understand the kind of VNFs, virtual network functions, network slices, microservices, containers, data repositories that shall be needed to serve the respective applications. Only after this stage we could actually identify as to what aspects can or should be standardized in the application domain. So when we talk about technology, it reminds me of our Abdul Kalam saying, in terms of getting kids working together and motivating them, teacher is the most important. Now, how do you guys leverage or motivate or guide them? You are all the faculty and senior researchers who would be faculty very soon. So the onus is on you people to develop such a strategy, such an approach to make sure that the students you teach them, they really get understanding of where the technologies are going, how to leverage the new paradigm, how to build a structured approach in analyzing and solving any complex problem. That is something we don't teach today in our colleges, engineering colleges particularly. So I think, so these are some of the other things that I'll not go into. So in conclusion, there's a small break we'll have after this. So good judgment, as they say, comes from experience. And experience, well, that comes from poor judgments. I think we have already had quite a lot of share of our own of poor judgments. So and we should be experienced enough now to make sure that in future we can make all the good judgments. Okay. So I think before we move to the next thing, I'd like to stop for questions. Any questions? Let's have some questions, and then we can, proceed to have some other thoughts on the design approach, and analysis and all that.
Yes, sir. So till now, so we are having one questions from the participant.
Yeah.
And the question is, so what is SLAC in IPv6? SLAAC SLAC in IPv6.
I'm not too sure. I'm not an IPv6 domain. I think you can just Google it and find it, to be honest. Slack. I'm not very familiar with all the acronyms. Why? Because I'll tell you, I'm not a software person. I'm a engineer from an old breed who has understood at the system level, design level, architecture level. I understand these technologies, but when it comes to implementing or deep diving, I also rely on my young researchers, young design engineers and all that, to be honest.
Yeah. So the next question is, what is blob transfer?
Yeah, blob transfer is, bus, like it's a you have seen bus transmission. You collect the data, condense it, and then you transmit it as a blob, as a burst, compressing all the whole lot of data into one compressed package, and then transferring it as you can say, like it's like a zip file, zipping it and then transferring it, then unzipping it. Blob is some like a very, very compressed block of information and data.
Yeah. Thank you, sir. So the next, so we are having one of our participant who want to have a word with you, and so he wants to ask you the question directly. So I'm unmuting him.
Please go ahead.
Yes, sir. Yes, Mr. Sabyasachi. So you may please put forward your question.
Thank you, ma'am. Good morning, sir.
Morning.
Actually, I am a physical layer researcher, basically. So while going through these things, what I got through is that even at the higher layers, also in IoT, we are having the connectivities. Like in case of our 5G, we are having two complementary technologies: the massive MIMO and the millimeter wave technologies. So, which massive MIMO would provide the massive connectivity, whereas millimeter would provide the directivity, or rather a constant connectivity, a seamless, reliable connectivity. So the same thing is actually here also mentioned as in the name of massive connectivity and like seamless connectivity. So as in like these two technologies, whenever at the physical layer we are dealing with this, we always find that the requirements or the system requirements are quite contradictory to each other. So do you find the same thing at your level of work too? And if so,
yes,
how do you really optimize it? Because as a researcher, while studying many papers, often we get confused, like what exactly the people are aiming at. Yes.
Very interesting question. So I think in life you cannot have your cake and eat it too. Okay.
Yeah.
So whenever there's a contradiction, you always reach a compromise. Now you say how to identify the best sweet spot. You need to identify the sweet spot, and for that, you go into not have a sweet spot for general which you can generally applicable. You need to go into a particular use case, a set of use cases which you are considering, zero into some use cases, then see what is more important, what is relatively less, and how much you are willing to compromise one feature for another. So you need to reach a trade-off, a compromise, a rational compromise, which is a sweet spot for that set of use case or that one use case. Then similarly, for different use cases, you have different sweet spot which shift from here to there. So something on the, you can say, one side, so some other on the more tilted more on the other side. So this will vary always, and this is nothing new. And the simple approach is do not try to generalize these things. You don't try to have your cake and eat it too. This is a saying of old generation wise people. So, and you know, those thumb rules of the wise people, they are applicable in technology also, by the way.
Yes, sir.
Yes, sir.
Yes, thank you, sir. So basically, the thing is that we have to follow the particular use case and do the work with respect to that. Exactly.
So
thank you so much.
I think in research you always say whenever you cannot generalize an algorithm, you don't find any hypothesis is applicable. Generally, you start constraining your parameters. So in the constrained environment, certain things are applicable. The moment you start opening up, they start becoming unvalid. They don't become valid. They become NP hard and all those kind of scenario. You know?
Yes, sir. Yes, sir. Thank you so much. Thank you so much.
Yeah. Anything else, or should I move to my next section of talks?
So we have one more participant, sir, who wants to like.
Go ahead. That is more important. Well, 1 to questions are more important than my next set of thoughts, though they are also very interesting. Yeah.
Yes, sir. So yes, Mr. Love Raju.
Yes, ma'am. Yes, madam.
Yeah. So please put for your questions.
Good morning, madam.
Good morning, sir.
Sir, good morning, sir. N. Kishore Narang, sir.
Yeah.
Thanks for unstoppable speech regarding 5G and all protocols and layer architectures. Sir, my question is, sir, the researchers may have regarding layer architecture. Some researchers may have used five-layered architecture. Maybe some researchers may have used 6-layer architecture. So, is there any particular layered architecture for IoT?
So, if you really ask me, the actual layers remain the same. Okay,
yes, sir.
You
yes, sir.
collapse and merge them when you are writing your own stack. That's a different thing. So, and if you really see, all these layers also have some kind of core characteristics or some open standard. They are not constructed by one single protocol or some single standard.
Yes,
each layer comprises of multiple, protocols and standard open standard IETF RFCs. It's a combination of different IETF RFCs. Now, it's a combination of them. You may call it like when you're not able to, in a structured manner, isolate each layer when you are writing your application, then we say, okay, yeah, we'll call it a collapsed application layer model. Okay, so we cannot, isolate presentation layer with a session layer, but there are certain use cases where you can actually structure where you can isolate them. Okay, so it is basically the way there's nothing wrong. You will always find, if you really analyze any number of layer architecture, there will be 7 layers actually.
So, yes, sir. Yes, sir.
So there's no confusion, no contradiction, nothing to worry about that. Okay,
yes,
whatever they may call. Like some people see, the problem is today we have so much knowledge to acquire. We do not have time to study everything. So what happens? We have a lot of pseudo intellectuals, pseudo researchers, pseudo designers, and they try to become pseudo professionals and intellect. They say, no, I know this. I've done this in a single layer. They don't realize Phi and Mac cannot be combined.
Yes,
Phi is a different thing, Mac is a different thing, but they'll say, no, I've got my communication technology, I've done my proprietary modulation and software, everything. So that's by this thing, I have got a 1 layer only. It doesn't make it 1 layer because they said so.
Yes, sir.
So
thank you so much.
So let's keep that in mind. So these are all people in the field, they may claim anything. But you as structured researchers should be able to debug it in a moment and then see, oh yeah, okay, let him actually has got those 7 layers if they change. Because see, when they defined this OSI model way back, okay, how many
Yes, sir.
decades back?
Yes, sir.
4 decades back, there was a structured approach. Now you see what is happening is, with time, we are like we have the IC integrated circuit. Earlier there used to be diodes, transistor, MOSFET, all those components were discrete. Now in a IC you have all those combined. In a SoC you have multiple cores combined. Does it mean that you have only single core architectures? No, there are so many individual components within that, but they have compacted so you can deal with it as a one package. Does not mean it does not have further granularity in its architecture. Okay.
Okay, sir. Thank you. Thank you so much.
No, sir. Thank you, sir.
I'll move to my next level. So now let's talk about something about the industry, because I think I'm coming from industry, so I'm expected to even tell you where as a nation we are going. I think let me just switch off my video. People do not get defocused. Okay. So, we are already going through a very, very difficult times. I'll not go into the same thing that I repeated that day. Okay. But whenever there's a, these kind of problems, what we are happening is there's a crisis, but it also brings opportunity. As we all know, global business dynamics is going to witness a sea change in the coming times. All nations are now delving on their exit strategies from China and becoming self-reliant. Today, the world is in pursuit of new business models. India, a youthful nation known for its innovative zeal, can take the lead in providing a new work culture. India, with the right blend of physical and virtual infrastructure, can emerge as the global nerve center of multinational supply chains in the post-COVID-19 world. But the only question is, can our engineers rise to the occasion and seize this opportunity? Electronic brands, everybody talks about electronic brand, but from electronic brand from India shall epitomize the ultimate goal of innovation and intellectual property, realized in a tangible and mass-produced form. These brands need to be carefully designed and built to satisfy a concrete customer requirement. They would represent the ultimate marriage of hardware, firmware, software, and apps ecosystem. They will combine multidisciplinary skills beyond engineering of electronics and embedded software, such as industrial design, user experience design, packaging, branding, and product marketing, etc. So what is needed to bridge this chasm between India's large pool of engineers and talent and our aspirations to be a country which can have electronic brands from India? The aspiration is to achieve the ultimate goal of electronic brand products or systems or even software for that matter that are conceived in India, designed in India, and made in India but used and sold worldwide. So strengthening the innovation and R&D ecosystem and enabling conception and creation of world-class products from India. What do we need to do as a nation to make an Apple or a Samsung out of India? Or for that matter, Microsoft or Google out of India? Can our Tejas, which is well known for communication, be like Ericsson of the world? Building a talent pool of creating workforce capable of helping us to realize this vision and creating markets for these made in India products is a challenge. So what is the mantra? The mantra is very, very simple. Innovation-led design and design-led manufacturing. This seems to be the only way forward to break this impasse. If India wants to be a serious player in this competition, while also fulfilling perennial urgent goals of boosting manufacturing and creating jobs, a number of fundamental changes in policy and mindset are necessary. Policy I'll not get into. The government is trying to do there enough. Okay, but so these are some of the things that let me touch on what government is trying to do. So you already heard of Atmanirbhar Bharat mission. So what they are looking at, this building of self-reliant India will stand on 5 pillars. Economy that brings quantum jump rather than incremental change. Infrastructure that becomes the identity of modern India. Our system that's technology driven. Demography, our source of energy. Demand, harness its fulfill potential. So Make in India needs to move. We have the slogan by our PM long time back. I think we need to change it to Make in Global India. Conceived, designed, and manufactured in India for the world. I don't know how many of you know that on every 11th May, we celebrate National Technology Day. This year, India celebrated the 29th National Technology Day. This day acts as a reminder of the country's technological advancements. National Technology Day holds a great importance because on this day, India achieved a huge technological progression. It was a landmark moment in India's history. We remember the exceptional achievement of our scientists on this day in 1998 when they successfully carried out nuclear test at Pokhran. On this day, our nation salutes all those who are leveraging science and technology to bring a positive difference in the lives of others. You'll say, why I'm talking of 11th May? Because the theme of this time, National Technology Day, was restart. And look at the beautiful acronym and the explanation what they got. R for rebooting the economy through science, technology, and research translation. Operation Restart, and the mission is making global India. Now, how do we do it? And when we talk about this, how do we do it? It takes me back to my own engineering days when I read this definition of engineer in 70s. Okay, let me just read it out to you. It's very, very interesting. An engineer is a person who passes as an exacting expert on the basis of being able to turn out with prolific fortitude infinite strings of incomprehensible formulae calculated with micrometric precision from the vague assumptions which are based on debatable figures taken from inconclusive experiments carried out with instruments of problematic accuracy by persons of doubtful reliability and questionable mentality for the avowed purpose of annoying and confounding a hopeless chimerical group of fanatics referred to all frequently as engineers. Is this the definition that you would like to be? I'm not happy. I don't like this definition. And that is why I've shown this and read this out to you. This is the kind of definition that people throw at us of definition. These are why? Because this is the way today's engineer behave. Even today, it is valid after 40 years. How do we change this? If you really ask me, engineer is an enabler of change. Sorry for all that regressive remarks, but positively speaking, the engineer is an enabler of change. And he or she is equipped with the ability to take society's grand vision or magnificent concept and literally make it work. In a world of increasing unpredictability, the role of the engineer assumes a critical level of significance. The day of the ivory tower academia-bound engineer are over. The engineers of today and the future must acquire more than a nodding acquaintance with the concept of sustainability in all its aspects: social, environmental, and economic. Innovation. Let's talk about innovation. It is what is the purpose of innovation? It is there to improve the lives. Indians have played a major role in bringing innovations to the world to improve lives of its inhabitants from time immemorial. Be it from the times of Aryabhat, who introduced the world to the power of zero, or in recent centuries, scientists like C.V. Raman, Satyendranath Bose, and many more. Amar Bose, how many of you guys know that? The global minister of sound, the wizard of sound who revolutionized sound, the engineer who changed the way the world listens to music. He showed the world how forefront academic research can spawn a global corporation and how science can directly change our lives. Bose Incorporated has been very aptly called the Apple of the audio world. He went into business so that he could do interesting things that hadn't been done before. Can we have a few more engineers like Amar Bose? Again, my question is, do we Indians have it in us? But most perennial question is our education system conducive to innovation? And what is innovation? Everybody is harping about innovation. Some say innovation is the key to India's rise in electronics and global arena. But how do we innovate without the competence to innovate? The basic onus is to build the competence. Now, let's understand what is passion. Passion is everything. You give that one emotion to anything and you are bound to excel. Passion helps you enjoy the journey as much as achieving the goal. Passion is the lever that helps lift the mundane to extraordinary, the mediocre to excellent. You will say, how do you know when you are passionate? I think look into yourself, ask yourself, and you will know. anything that you love doing or which makes you happy, the most successful people are those who are able to select careers matching their passions. However, but I think, let me give you my own example. When I did my engineering way back in 77 and then I left my last job in 81, I always wanted to pursue the career in design. And it was my passion. Yes, my life for last 4 decades has not been an easy this thing. I've not maybe achieved a lot. I've not become a multimillionaire. But the kind of gratification I have, my passion, my commitment to my this thing choice of design, as you already saw on that my last slide, that design is our religion and we are fanatically religious. So it's a passion, and what it makes you rumble through all the tough times, hard times which I've been through time and again with a smile. I remember in early 90s or late 90s when I was going through a very, very rough patch in my design house business or activity, commercial success. My friends used to get frustrated by looking at me, and I would ask them, why are you frustrated? So because we know what kind of problems you're going through. You've not got a project or money for the last 6 months, but we do not see you depressed. And they used to feel depressed. So and I used to tell them that, look, it's that, irrespective of the money that comes in, the kind of work I'm able to do in every week, every month or something, which I know that nobody could have done it better, nobody could have done it like this, or nobody could have done this at all. That gives you gratification that keeps you surviving on thin air, on air and water for next few months. So that is the kind of passion that we need to build into ourselves in case we are really, or identify. Everyone has something inside them, him or her. We need to identify that. What is that excites us? What is that can take us far off without bothering about our day-to-day problems? So that is what passion is. However, in age of intense competition, everything gets reduced to numbers. Maybe things are easier to understand when they are presented as data that can be compared favorably or unfavorably to something else. So facts and records become far more important than the effort and passion that went into achieving them. So what is the missing link? The culture here is one of success based on academic excellence, studying, learning, practicing, and having a good job and a great life for upper India, not the lower, because I see two Indias here. That's a lot like Singapore or so many other things. Study, work hard, and you get an MBA. You will have a Mercedes, but where is the creativity? The creativity gets left out when your behavior is too predictable and structured. Everyone is similar. Look at a small country like New Zealand, the writers, singers, athletes. It's a whole different world. But in India, everyone wants to become an engineer or doctor. Why? Because they'll get a job in MNC. Is that the right way? So what is the root cause? Unfortunately, education too has been reduced to a game in numbers. At the end of school years, all you are worth is the score you achieved at the board exams. It doesn't matter how passionate you are about your studies or how you gain mastery over an aspect that particularly intrigued you. Education system in India over the time has become qualification oriented rather than knowledge oriented. The key focus of education shifted to providing and acquiring qualification which are expected to get you placed in reputed or global organizations. It might be the fact that higher education is about critical combination of fundamental research and applied research that leads to design of new technology solutions and to some extent identifying new skills or barring the skills. The Indian heritage script on historical places is one of the examples. It would be better to restore or develop the earlier values in such a way to meet the requirements of the society at a global level. So how do we build knowledge economy in society? Our education system needs to move to a paradigm of comprehensive and inclusive learning-based education, particularly in the higher education institutions. Once the youth is equipped with comprehensive knowledge of their respective domains, they would easily glide into the research at the global level in fundamental research as well as applied research in their respective fields. Need of the hour is to focus on multidisciplinary approach in education with super specialization in niche area. I hope our new education policy brings some actually desired changes. So another thing that we are facing today is Indian so-called design engineers who are already in the field are not actually doing any design at all. Rather, they are interested in only getting paid for soft skills and quickly moving on to managerial cadre. They are not willing to work in a proverbial trench for 15, 20, or 30 years and become specialists or designers in any specific domain in electronics or whatever. We need, as a society, to make changes in the values of our young generation mindset so that our engineers like to stay in design and not move to managerial cadre in a hurry. Remember, in 70s, 80s, and even 90s, our engineers went abroad for further studies to build up the competence. Since during those days, we did not have an ecosystem in place in India to utilize their competence, they stayed there and contributed to the global electronic system design and manufacturing ecosystem. Today, Indian design engineers are very well recognized and respected the world over for their competence to innovate and now for their ethics and global leadership qualities which we are seeing. Satya Nadella, Sundar Pichai, and they are umpteen examples, they are all Indians who went there and stayed there. So another aspect to consider is the mindset they need to develop. It is important for them to be visionaries to a certain extent, since that is what helps them create good technology, keeping in mind the fast pace at which we are approaching an accelerated futuristic era. It is important for the engineers not to only know how to write a code or program, but also think and plan strategically, know of ways to manage once they have been executed the idea, and be capable of applying a pluralistic thinking method to encourage sales by understanding the consumer's exact need. We design something, we research something which is not applicable or useful for anyone. Does it really mean anything? We are just gratifying ourselves. We are living in a fool's paradise by doing something, designing something or researching something, innovating something which nobody has used. So another basic gap is the design houses in India. So I'm one of those, design houses, but I find myself a rare species, an extinct species in design houses. To meet the global expectation from India, another crucial link is our design houses. Most of our design houses are merely design implementers, not creators. As in civil engineering, we have architects and contractors. Our design houses are performing the roles of contractors and are happy to merely meet the customer specification of the product. Maybe it is because a contractor makes more money than an architect. It is high time that our design houses took upon themselves the responsibility of being the design architects rather than mere design implementers. The design houses must start building domain expertise in their respective field and try to become the friend, philosopher, and guide to their customer. You'll say, why? How? This is because, you see, when a client comes to a design house or designer, like I've been dealing with a lot of clients, they themselves have a vague idea of their own problem. They look up to designer to solve the problem or design a system out of which they can make some money. So what is my job as a designer? My job is not to give them what they want, what they have identified requirement, but give them something what they need, which even they themselves have not realized till now. They saw a business opportunity, they came to me, they are willing to pay me something to design a product system solution because they can make more money. But so my responsibility is that I need to get into the depth of that domain, understand what it entails, and then give him, develop a system, product, system solution, what will actually make sense for next 5, 10 years to my client. Do we have that kind of temperament in our designers, in our design houses? So we need to first build up the competence before we focus on innovation. So how do we accelerate and de-risk the career journey? There's a whole lot of system approach that we talk about. I think I'm already getting over my time, so I'll maybe some other time. But I'll just reach on something. This is a very, very topic, this thing. But so I'll just look at this and close this thing. How do we bootstrap the competence in design? We need to address this vital gap in the fundamentals taught and their applications in product system realization through the understanding of design paradigms. We leverage all the theoretical learnings and introduce students to the vast applications of concepts learned through exposure to an approach to the integration of comprehensive design experience with the engineering curriculum. A few learnings needed for system design: grasp fundamental concepts in product architecting like customer need identification, requirements formulation, functional decomposition, as well as function form mapping during conceptual design. Understand the platform concept and be able to prioritize drivers of modularity and product platform design. Enumerate metrics for quantifying commonalities within a product family. synthesize and analyze existing architecting approaches to enhancing creativity while reducing ambiguity and complexity. Utilize out-of-the-box holistic system thinking in developing a system's conceptual model and architecture. Define system architecture, modeling, form, function, structure, and behavior. Describe how a system's function emerge from its form and behavior. Distinguish between the notions of a system, product, service, and a project, and how each creates value and competitive advantage for any enterprise. Distinguish between incremental innovation and radical innovation when creating new solutions. And understand and apply a 10-step design process. It is in the preceding slide, so you can go through the slide deck. I don't have time to go through that this thing. Build a knowledge base of latest technological innovations. Develop new concepts and designs by participating in shared sessions that focus on a limited set of core issues connected to real-world implementation. Understand and practice the crucial design imperatives: safety, security, reliability, standards, compliance, and environmental consideration. Develop a holistic and system-level perspective on smart, sustainable electronic designs. So whether we talk about designing anything, end-to-end to IoT, LT to 5G, big data, artificial intelligence, quantum computing, anything, these things have been coming and going, and they will continue to keep and go. What do we need to do? So just giving a core example, what we need, as we know, every two IoT application actually our solution needs cross-domain expertise. Internet per se has been considered the forte and playing field of software professionals, but IoT brings a new challenges in the way of sensor fusion, communication technologies, energy, power management of the edge nodes. Unless a design engineer can design most optimized edge nodes and communication nodes, the solution shall not pass the acid test of reliable and sustained performance in the field deployment environment. So what are the competencies needed for IoT? Basic electronic fundamentals, including but not limited to sensors, analog, power, RF, and various compliance issues in hardware design. In-depth understanding of different communication technologies, protocols, standards, particularly relevant to the domains relevant to your applications. Understanding of security, privacy, socio-ethical implications of the solutions, services, and applications you are trying to develop. Embedded processing, data analytics, and other software skills are already considered as a must. So what are the gaps in our engineers? Hardcore and comprehensive product system design, we do not have any competence there. Hardware design, we do not have any hardware design engineers in India anymore. RF, analog, and mixed signal designs, very rare species to find. Reliability and compliance issues in design, people only learn after 20 years of experience in the industry. These are some gaps that we can, if people can focus on bridging these gaps as faculty, whether by inviting industry experts by teaching or yourself upskilling yourself to teach our students these things. I think you will be doing a great favor to the next generations of the country. Then a lot of people talk about, no, I am into AI, ML and all that. So let me warn them. See, most of the AI, ML people today are also working at a superficial level. If you really want to become an expert in AI, ML and all this big data and all that, these are a few core subjects that you really be good at. Yellow ones are the really critical. The white ones are also preferred that you understand. Linear algebra, probability and statistics, multivariate calculus, design and analysis of algorithms, random processes or advanced probability as some people call it. You need to be expert in all these domains to actually start working properly in AI, ML. Otherwise, you'll be sitting in a corner of an MNC doing some small test case or training model, this thing, and you'll say, I'm in AI, ML. Okay, discrete math and graph theory are also very, very helpful to become a good AI, ML, developer or a professional for that now, or even researcher for that matter. When you're doing some kind of PhD, some research in the AI, ML field, okay, unless you have good grip on all these subjects, I don't think you will be able to do really any good research. You may again copy paste a few papers and get your PhD from somewhere, but a real research which will really make a difference, a real gratification of doing some real innovation, real research which qualifies you, for real recognition, will be really missing. Okay, so with that, I think I'll just close my thing because I'm already past my time. Okay.
Thank you, sir.
Thank you. Any questions?
Sir, there was a question. What is block transfer?
I think I already answered that question.
Okay. Sorry, sir. Yeah.
No,
Thank
it's
you, sir. Sir, may I request Bharat sir to please acknowledge sir for such an excellent session. The participants are already giving their comment in the QA section. So may I request Bharat sir, please?
Hello.
Hello.
My voice is clear?
Yeah, it's quite okay.
This is clear, sir.
Yeah. Thank you, Narang sir, for such a on the disruptive technologies, which is going to be used for IoT. So I'm thankful for giving your time and precious time and be with us for this. I'm really thankful for your cooperation and time. Thank you so much from my side. Thank you, Phil.
Absolutely. Thank you, Professor Bharat, rather giving me an opportunity, because I look forward to such opportunities. You know why? So I go and talk in a lot of colleges to the students, but I think talking to teachers is much more gratifying. You know why? Rather than training 500 students, if I'm able to, train or share my perspective with the faculty members, 50 faculty members, I think they will be able to, disseminate those very thoughts and knowledge to 5,000 students in next 1 or 2 years. So I think it's really gratifying to, share my experience, perspective with the faculty members of the premier institutions of India. And that really is the thing. I'm rather grateful to you and your program to give me an opportunity of sharing my thoughts to help people evolve as a good researchers, designers, faculties, and engineers in India. Thank you very much.
Thank you so much, sir.
Okay, will
Thank
that
you,
be
sir.
all? Yeah. Yes.
And sir, on behalf of Professor Ratnajit Bhattacharya, sir, we also like to thank you for the talk. Sir is busy with some academic workload, so sir could not join the session. So
No problem.
thank you, sir, for a wonderful talk. Already we are receiving a thank you note from all the participants in the QA section. Thank you, sir.
Thank you very much.
So with this, we are closing the first half session for today. There is a small announcement for all the participants. Today we are having the last MCQ for the MCQ number 5. The details are already uploaded in the drive. I request you all to please check the drive link for all the details. So the MCQ will be having 10 questions. The time duration will be from 2 p.m. to 2:15 p.m. I request you all to please join for the MCQ. So we will be joining again by 12 noon for the second session. Thank you.
Thank you. Thank you. May I log off now?
Yes, sir, please, sir.
Thank you. Good day.
Thank you, sir.
Hello, this is Fidos.
Hello, good morning, sir. Yes, sir, you are audible. Sir, we have given you the presenter rights, sir. Can you please check once whether you can share your slides or not?
Let me check. Can you see my screen?
Yes, sir.
Yes, sir.
Let me know if it goes out now. Now it is not visible, I guess, right?
No, sir. It's a blank screen, sir, right now.
Okay. Let me try again. Now it is visible.
Yes, sir. Now it is visible, sir.
So we have minutes. So the participants will be on mute, right?
Yes, sir. The participants will be mute, sir.
Okay. And if they have a question, they can ask me on the chat, right?
So in the Q&A section, sir, at the bottom, sir, there are 3 dots. In the dot, you will find the Q&A section, sir. So there, all the questions will be filtered.
WebEx Q&A, right?
Yes, sir. WebEx Q&A, sir. So in the 3 dots, sir, at the top, sir, you will find the Q&A section. Yes, sir. And sir, if any participants is willing to have a verbal discussion, in that case, we request the participant to please raise their hand. We unmute them and then they can interact with you.
Okay, I got the Q&A.
Yes, sir.
All right, Firuza, let me know, whenever. Currently, I'm stopping the sharing.
Yes, sir. So we will be starting in another 3 minutes, sir. If it is fine, we requested the participant to start at 12. So everyone will be joining by 12.
No problem. I'll wait for 3 minutes.
Yeah. Thank you, sir.
Welcome.
A very good afternoon, dear coordinators and participants. We welcome you for the day 9 second session. We are very fortunate to have with us Professor Firdaus Ahmed Borburia, sir. Sir is Associate Professor in the Department of Computer Science and Engineering at IIT Guwahati. Sir is also Associate Dean of Research and Development. Sir is working in the area of security in cloud, SDN and NFV, biometric security, security issue in Internets of Things, and intrusion detection and prevention system. Sir is working in the area of network security since his MTech time and is working and is also associated with many other organizations, helping them to come up with the problem statements and solution. So with this, I would request Firdaus Ahmed sir to please start the session. On behalf of E&ICT Academy, IIT Guwahati and NIT Patna, we welcome you. Please, sir.
Thank you very much.
Yes, sir, you are audible. Like the voice is little bit breaking, sir, in between.
Okay. Just give me a moment.
Yes, sir.
I hope.
Sir, may I request you to, if you can switch off the video, I think so then the network quality will be
I
little bit.
will do that. I will do that.
Yeah.
How it is? Is it better?
Yes, sir. Now it is better, sir. Yes, sir. Yes, sir. It is better, sir.
Okay. I will keep the video off. Good afternoon, one and all. Thank you very much for attending the session. I'm Firdaus. I'll take you through the IoT security, some of the issues and challenges what we have on day-to-day basis, and specifically the issues related to deployment, issues related to real life, and also what are the opportunities to work on the IoT security related research areas. The agenda is very simple. We'll discuss how secure of IoT is, what are the issues and vulnerabilities, what are the key aspects for securing IoT solutions. So these are the three focus areas. I shall be going back and forth between these three topics. This is in best interest of and everyone's understandability. There is so this particular lecture doesn't assume you need to have an IoT Pro or something, or you need to have like heavy programming background. No, a basic understanding of programming, a basic understanding of working with IoT devices is good enough to understand this particular deliberation. By now, you must have heard and a lot about what IoT is, what are its usage, examples, etc. And I do not want to give you yet another definitions and elaborations about it. But to be, from security point of view, it is nothing but some networks of physical objects. Physical objects are devices, maybe vehicles, it may be wearables, it can be buildings, it can be consumer electronics, it can be some softwares, some sensors, whatever we can imagine. Examples, smart city, smart supply chain, smart home, etc., etc. Quite a lot of examples are there. We have seen this kind of slide everywhere, like the scale of IoT. is visible?
Yes, sir. The screens are visible, sir.
Okay. So I'm sorry, not there. So this was the agenda I was about to talk about. How secure is the IoT environment, the issues and vulnerabilities, and some of the aspects for securing the IoT. I talked what is IoT, its example. We can see wherever we have physical objects connected in an IoT system. And I was talking about this slide that the adaptation of IoT in last decade was exponential. It was very rapid. The number of connected devices very, very high. Now, the adaptation we can adaptation rate of electricity or telephone. And we have reached a stage where per person in average is multiple times of the number of people on the earth already. So it is nobody has the exact objects or smart already there. So that makes a very, very challenging environment. Now we call it IoT. There are different names coined by different organizations. There is a name called machine to machine, which again means IoT only. Cisco has defined it Internet of Everything. Datanova said that Internet of Anything. And there are personalities who called it as world size web. And of course, I will call it, but Sky movie. Okay, that's my definition. Now, whatever may be the definition, or the name we call it, the subject, the matter. How does the IoT ecosystem looks like? The IoT ecosystem has 4 different components mainly. The first one is the people, who are the ultimate consumer of the traditional IT ecosystem, where the people used to interact with. There comes the data, sensors, or it can be some historical data or any other mentioned physical devices, objects which are connected to internet, which can be intelligent, through which decision can be made, etc. Doing the right thing at right time by right person. So a whole lot of ecosystem. Now, early system used to work always, as human as the end user. But in case of IoT, it's a machine-to-machine system. So one machine or a sensor can be consumed by another machine to do, where the human beings are not that much involved, or it can be there is a possibility that human or seen when an IoT ecosystem is working. So that makes even more secure. Human being is intelligent and she always can take decisions looking at many different parameters. But when we have a machine or a process which is supposed to do a particular thing, it may not be able to look at other aspects like security, etc. So looking at how smart are the IoT devices? IoT devices can be as smart as much as we can imagine, thanks to the advances in artificial intelligence and data sciences. So IoT devices became very smart. There are taken by industrial IoT devices, for example, by in controlling the electrical load balancing, power grid, or maybe a municipal IoT where it routes traffic in a city. So those are very, very critical applications, and that can be very intelligent. Now, traditionally, there were, if we look at the stack design, there were infrastructures, there were applications, and the applications used to run infrastructure using some unified platform, maybe in the form of operating system, virtualization, etc., etc. But in case of IoT, the infrastructure, first of all, the application became a particular type. So in case of IoT, we do not build a IoT platform. Rather, these are application-centric infrastructure on which there is an infrastructure interface, and we have an application-enabled platform. And on top of that, the IoT application. There are enormous advances in the device and sensor innovation that also in the chain. And there are other areas like data integration, big data, analytics, control system, application in them makes it even more complex as an ecosystem. There are newer business model, there are newer partner ecosystem, makes it pretty complex as a structure. If we consider one sensor, one device, they are pretty easy to understand. But when we have an integration of several IoT devices in an ecosystem, the environment becomes complex. So what comprises of IoT network? There are two parts. One is information technology. All of us know pretty well that what information technology is. It's basically hardware, your software, your process, etc. And then comes the operation technology. And both of them combine together to form smart objects. Now, question comes like, what is operational technology? Now, taking a decision depending on an input, for example, a human operator controls a chemical plant. So the chemical plant is a physical entity, but then the human being controls it depending on certain parameters. That's operational technology. Now, where we combine them together, we get, and that's the basis of IoT. There are a lot of hypes around IoT. People try to find every possible piece of the word IoT to different ecosystem, but IoT has its own usage already beyond all these hypes. There are municipal IoTs like smart cities, smart grids, which are doing fantastic job in providing real-time information and controlling critical infrastructure. There are industrial IoT where connected factories, smart agriculture, logistics and supply chain management, etc. are very, very popular. Then there are medical IoT where there is a smart hospital. There are remote investigations happening. There are electronic medical records that are maintained remotely. All of them have made a ecosystem is adding value to our existing infrastructure or existing industrial capability. Now that makes it very, very critical. We cannot, maybe we can tolerate a smart fridge not working as per my desire, AC as per my wish. But if it is an industrial IoT and if it doesn't work properly, it can be catastrophic. For example, if somebody, if a bad element takes control of the smart grid and turn off the power for a city, or even supply the wrong voltage, all of that can lead to some very serious consequences. Similarly, factory, if it is an automated factory using connected grade IoT equipments. So if some of them fail, there may be hazards. So, and there are like a few incidents that has happened already. So all of them makes it very important that all these infrastructure has to be secure. What is the power of IoT? We have connected things, which are objects, as I mentioned earlier. It can be controlled, and these connected things using which possibly we can control almost anything depending on our design. And from that, what we can do is we can gain some insight about what is going on. And depending on that insight, some action can be taken. That's the kind of flow that we are seeing in IoT arena. With that, there are tectonic shift, or there is a continental drift in the security, trust, and dependability looked at. Real life, when we are among very diverse group of people, trust reduces. Do not talk about our personal or very important financial matters in front of strangers whom we do not know. Same thing happens with IoT, with the diverge systems with which are connected together. The level of trust that was in case of traditional IT infrastructure, that got reduced quite a bit. There is a challenge with the dependability and integrating multiple products, services, concepts, products together from different vendors. The dependability also becomes a question. Then there are issues with security, as we are converging multiple tools, methodologies, operating systems, applications together in devices which are not very generic, or which are not or it doesn't have enough memory to bear the load of another security environment, like in endpoint security. That makes it very, very critical. Let me give you an example. All of us are experienced, or all of us have seen or utilized CCTV cameras. And these days there are IP cameras, and they have an operating system, so they are an IoT device. Now these IP cameras, as it has an operating system, I'm sure there will be some bugs in those operating systems. Normally in our traditional operating systems like Windows 10, what we do that on a weekly basis or on a monthly basis, we get patches. We install them, we make our system secure against all the security loopholes that is discovered recently. But do that with our CCTV camera? Possibly no. The other challenge is that this device manufacturer, their core competency is to fabricate and design a device. They are typically not very high-end software or security companies. In such a scenario, many a times the security takes a backseat. You will find that the systems are designed to work, not for trust, or not designed for security. So that makes it important to look at it. As we all know, the internet is a very, very broken place. There are several security challenges that are there on the internet. And of course, we have certain solutions around it. But then we cannot still say that that is the best possible solution, or it is a foolproof solution. There is nothing as such. In such a situation, when the traditional IT infrastructure, where we are struggling to have enough security in place, we are increasing the number of devices at such a level where we are talking about millions and billions. We need to look at the holistic of security again in a very, very different manner. If you look at terminologies like SSL, IPsec, antivirus, patches. I mean, there are so much of things to be done in case of traditional IT system, IT environment. And then when it comes to IoT, what else? What are the other challenges will be there? As it is a network system, it has its own operating system. It has its application. All the security challenges that are there in the traditional IT infrastructure, IT network, will be inherited to IoT. Plus, there will be IoT related challenges as well. So there are new landscape into the security. There, which might give it boost computation. Traditional, let's say DDoS attack can lead to availability. There are messages and documents that is in the form of zettabytes of data. There are spontaneous and massive attacks that are happening. Either there are transcontinental virtual organizations. That means one organization spread across multiple geographies using overlay or P2P or grid network, etc. Am I audible?
Yes, sir. So you're audible, sir.
Yeah. So, just remind me if there is because
Yeah, sure, sir.
I'm unable to see everybody, and I do not know whether my voice is reaching. Okay.
No, sir. Everything is going
Fair
fine,
enough.
sir. Yeah. Thank you,
Sure.
sir.
Thank you very much. So then why we should be concerned about IoT? It is just yet. So if it is yet another computer, we can use our existing knowledge of security to solve all the problems. We have same issues like access control, vulnerability management, patching, monitoring, etc. Having said that, just imagine that suddenly your network where you used to have or a few hundred endpoints suddenly becomes 1 million. Now, how do you manage that? And any one compromised device within your IoT network become a foothold for the attackers. That become bad for the attackers. So scale is one large problem. There are other issues like I will talk about it as I move ahead, but let me just brief you that traditional IT environment has an owner. Always there is an IT department. Machineries, servers, computers, laptops, softwares, networks, etc. In case of IoT, that may not be the case. An IoT network may be owned by a government industry or by a chemical industry or even by a medical, and those devices are actually owned by the end user or other there is a different group of people who actually deploy these. It may be the doctors who has deployed those, and it is under their ownership. So the traditional IT support is also not there in case of IoT device. So the other major security challenge is an evolutionary technology. It is not something like there is a sudden revolution and something came out. It is not that. It is based on obviously the hardware which is there for many decades, operating system on top of the hardware. Then the operating systems, the machines are connected over network. There is a web basically dominated by HTTP as a protocol, or maybe it's IoT equivalent in the form of COAP or something. There are mobile-based services, and then there is cloud integration to all of that. Why integration? Because by now you must have seen that in case of IoT, we love to store the data in the cloud. Reason because of availability, because of ease of storing, etc., whatever. You know it very well by now. All of them are ingredients. So whatever are there, in all of them is applicable to IoT. So the challenge of IoT is that it is inheriting a lot of the weakness of the traditional world and adding a new dimension to it in the security problem. That is one of scale, another is the divergence. So why does it look so bad? Why the IoT security area looks, so much challenge? Why there is so much of challenge in it. The breakers or the bad guys are having good time. There are automated network attack tools available at zero cost. That means you open source or even readily available tools are there, where the attacker need not have any knowledge of the system and they can launch indiscriminate attack. There are exploits available for almost the entire IoT stack. Ready executables are there. Either you can buy it or you can even freely use it. Or the worst thing is that you can use it as a service. Pay a few bucks and you get it as a service. You won't have to install the software or you won't have to buy it or anything. So that makes it even exciting for the bad guys. And then in case of IoT environment, there is physical access available. Many times these devices are available in the hand of bad guys. And what are the good guys or owners or the builders of IoT systems? They are still searching for secure toolkits. There are many, but none of, or at least none of them are close to foolproof. They are still searching for proven methodologies, some successful models, etc., etc. One way the owners are struggling, another way the bad guys are having a field run. What is the end result? The builders are cobbling together many components, and we are building a very fragile stack of, using a very fragile stack, we are building solutions. There is no visibility into the security or attack surface. And attackers are having very, very good time. The track record of IoT based systems is not good, or I would say miserable. Their Mirai botnet growth. So a Mirai is a botnet. Of course, the botnet is another topic which I cannot include. But imagine a system which is compromised, and those systems the attacker use to launch attack on other system. There was an incident in which thousands and millions of CCTV cameras of a particular brand of a particular OS version has been compromised. And those CCTV cameras were used to launch attacks on large financial institutes like Visa, MasterCards, etc. And it took quite some time to figure out where from the attacks are coming. Nobody would suspect a CCTV to be launching attack on someone else. And nobody will actually log into to the CCTV and try to patch the operating system of that, right? There are many others like Google Home and Alexa security breach, in which a lot of personal conversation records, etc., of certain individuals has been compromised. There are cases of even hacked baby monitor, where the attackers actually made some infants suffer by showing some scary stuff into the baby monitor. A baby monitor is nothing small cradle where there are images and videos are played for the babies so that the baby remains silent. But then there is a nice article, Why Baby Cries. You can read that and find out like what has happened. So the hackers has their imagination. I mean, the bad guys has their imagination, which doesn't have any limit, right? So forget about industrial IoT. They are even trying to hack into baby monitor. So IoT what are the security needs of? The first thing is that increased attack surface. The more you expose yourself to the outside world, more is the attack surface. As the number of devices are large, so the attack surface is large. What does that mean? Actually, the attackers has more number of device on which he can attack on. There is threat diversity because the IoT protocol stack and implementation till now it is not heavily standardized. Many OEMs or many companies are having their own way of implementing things in IoT system, and possibly it is going to be even diverse in coming days. Okay. So all that leads to, what is the impact is there are a lot of risk that needs to be handled or remedy has to be created. There are protocols which needs to be secured, and there are compliance and regulation. For example, there are many countries where you cannot even reveal your own health record. That is an offense. Forget about someone else's, but you cannot even tell if you have a disease or if you are suffering from something. You cannot tell another person. So there are stringent laws like HIPAA, PII, personally identifiable information. Okay, so there are many other regulations in Europe, America, and even now we have in India also we have a data regulation framework available. What does that say? That if you store data of someone else, what can you do? Whether you can distribute it or whether if there is a breach, what will happen? So there are compliance and regulations in case of IoT ecosystem. Regulations has to be respected and followed. So what can breach an IoT network? So it can be almost anything. Any node on your IoT network can be a potential breach in the network. Okay, we have billions of connected devices in secure and insecure location. Many times IoT devices are field deployed. For example, agricultural IoT, municipal IoT, they are deployed on the field and they are not under a roof or controlled by a security guards. No. So they are owned. They are many times, as I mentioned earlier, not owned or controlled by the IT department or the IT support service of the organizations. But then one thing that is very worrying, the data actually flows through those networks. If you look at the surveillance network of a city, the CCTV, they are also having the same thing. They are deployed on the field. They are not managed by the IT team, but then data flows through those, right? There are other sensors, for example, traffic control system, medical system, all of them has that weakness, and that can act as a breach for the IoT network. Now let's look at the IoT security paradigm. I have about 50 minutes. So what are the attacks on IoT devices? There are physical attacks. What one attacker can do, they can go near the device and probe on the device. Basically try to access the device using some technique, either through wireless or through a wired mechanism. Because the devices are field deployed, so attacker can have access to it. There are side channel attack. The devices, wherever they are, there can be an adversary nearby. So the adversary may not have access to the device, but can have access to, or at least try to monitor certain activities. For example, timing analysis. They can do the power analysis, that how much power it is consuming. fault analysis, electromagnetic, how much electromagnetic, what is called field that has been created, right? Somebody might look at the temperature, change in temperature, and try to figure out how much computation is going on, whether it is transmitting the data, and possibly what data it is transmitting. It is possible. If you look at the details of side channel attack, you will find out what all are possible. There can be environmental attacks, which may not be intentional, but as a field deployed product, there can be, the IoT devices can be affected from environment. For example, there can be interference from other devices. There might be unavailability of bandwidth, etc., etc. Then comes the cryptanalysis attack. Typically, when we deploy an IoT device, we would like to encrypt the data it senses and transmits. Now, these devices doesn't have very high processing or memory capability. And normally we know that any crypto algorithm are resource hungry. They need a lot of resources. Now, what does it mean is that we cannot use very complex crypto algorithm on IoT devices for the performance reason. Some mechanism which we think good enough, but they may be prone to ciphertext analysis attacks. Is that the attacker may try to find out, corresponding to the ciphertext or the coded data, what is the actual data. There are various techniques. For example, known plain text, which we know the plain text, so we can try to match that and try to, the attacker might try to figure out. There are chosen plain text attack. There are man in the middle attack. If you read more about it, what is the man in the middle attack is that two stations they are trying to send and receive. So the bad guy or the attacker comes in between, and if A is trying to send something to B, the attacker takes that from A and then reads it and then again relays it to B. So A sent, B received, nobody suspects, but then there is another gentleman, of course, gentleman within quotes, knows what is happening. Okay. Similarly, there are software attacks. For example, there can be malwares like virus, trojans, logic bombs, worms, etc. that can be launched on IoT devices, or IoT device might get infected from anyone or all of this. And the one of the other easy thing what attacker try to do is to have a denial of service. As I mentioned earlier, there is limited resource. So some of us may be familiar with the TCP protocol. TCP protocol is on a three-way handshake. The first stage is known as SYN. Second stage, I mean the initiator or the host A sends SYN to host B. When host B receives the SYN, it sends another message called, that means it acknowledges the SYN, and then while sending the SYN, the host B actually reserves certain memory that particular request. Now, what it should happen is that host A in return should send an acknowledgement, and then the data transfer should happen. What an attacker is that it can send a lot of SYN requests and remain silent, and that too using an IoT which doesn't exist. So the receiver, what will happen? It will dedicate small amount of resource for all these requests, but eventually, being it doesn't have unlimited resource, it will run out of its resources. Okay, so such kind of denial of service attacks are very common. Then comes the network level attacks. What all that can be there? That first is like monitoring and eavesdropping. An attacker can try to monitor what is going on across an IoT network and try to feed some data which it thinks it will serve its purpose. There can be cases of traffic analysis. They might try to figure out what kind of communication is going on and look at the packets been transmitted. There can be, again, denial of service attack in the network level also, that the whole bandwidth is consumed. For example, we all know that there is a command called ping. We try to check using, it's a ICMP message, or it's known as the control message of the internet. Using ping, we can figure out what is going on, or rather whether another host is reachable or not. But many of us may not be aware that there is a payload part in case of the ping command. Normally, when we test a network, we send a few bytes of data as payload, and the receiver knows that it has to transmit back those bytes. Then only we know that the communication is successful. Now, instead of sending a few bytes, what an attacker can do is that it can try to send a few megabytes of data, or a large number of such ping request. And what that actually will lead to, it will actually the receiver will crash because it won't be able to handle that much of data. Its bandwidth will be full. It won't be able to transmit or receive other data. There are other like node capture. And an adversary can actually take the control of the node from the owner. Node outage, one can actually drain all the power. Many of the IoT devices runs on battery power. So if somebody can drain out the battery, it will not work. False node, somebody can place some false node inside the network. Routing attacks, or replication attacks, somebody can actually try to send the replicated messages. You are sending A to B some message, let's say increase the temperature by 5 degrees. What it can do is it can capture that message and later on send once more. Now what will happen? That two messages are there. So instead of increasing the temperature by 5 degrees, it can possibly increase by 10 degrees. And if that happens in a chemical plant, the plant might melt down. So all that are real danger. So if we look at the effect, net effect, or the danger associated with IoT related attacks, it is possibly far more than the traditional attacks. It is not only breaching data, but it can actually control, or it can actually destroy something in the physical world. So that is why the IoT security paradigm is very, very dangerous. And where all it can go wrong? See, in case of military installation, where a lot of independent devices are there which are connected, or even VNet or vehicular network, weather monitoring, disasters, mitigation mechanisms, smart home, supply chain, health, agriculture, and whatnot. Almost all segment of IoT environment can be attacked and compromised. So that makes it very, very important to in a very holistic manner, in a systematic manner. If we look at know that security has a paradigm called CIA: confidentiality, integrity, and availability. Let me briefly tell you what is CIA. Confidentiality is that if I'm sending a message to you, no one else should know that what I'm sending, even if they have the message. That means I should encrypt the message, or I should message. What is integrity? That if I am sending a message to you, whatever I'm sending, you should receive the same. Nobody should be able to change the message. So that is integrity. And third one is called availability. That means if I am sending a message to you, it should reach you and you should remain available to receive the message. In case of IoT, you see the maximum attacks or threats are on availability. Some of them are like packet flooding. I mentioned earlier that send a lot of packets, make the recipient unavailable. There are vulnerability related attacks. I mentioned earlier, like every operating system, every application might have some vulnerability. And when they are discovered, the attacker might try to take advantage of those vulnerability. There are jamming attack, that if the IoT system is using some wireless environment, an adversary can jam the wireless network by sending signals around high power signals around that particular bandwidth of that particular frequency. There are black hole attacks. Of course, I cannot explain it here, but again, it is another attack where one host doesn't see another host, or visibility problem is there. If you're further interested, you can find out what is a black hole. In case of integrity related attack, you can have, an IoT system can suffer from selective forwarding. Means in case of a man-in-the-middle situation, the attacker can choose to forward certain messages and messages. Once again, think about a nuclear power station where the devices, SCADA systems controlling the nuclear reaction. If certain messages, for example, the nuclear plants needs to be cooled, they are many times water cooled. So if the instruction doesn't reach that the cooling has to be intensified, there is again a chance of meltdown or an explosion. Similarly, there is a Siebel common attack which can lead to confidentiality breach. Okay. So as we can see that across all these, where there is a increase in traffic intensity, we see more attack. Also, there are other preliminary stage attacks. For example, a node is compromised. There can be, implementation of malware inside the node, or inculcation of malicious node, placing a malicious node which is not actually owned by the organizations or the deployer, and also deploy equipment for intruding inside some of the nodes. Okay. Now, I talked about CIA, that is confidentiality, integrity, and availability. But there are other parameters beyond CIA, like authenticity. How about like whatever the message I have received and is written as I have really received from A, how do I know? That's about message authenticity. How do I access? For example, if I have an IoT device on which some action can be taken, for example, a plant can be turned, certain machineries can be turned on or turned off. Now, who can turn on and who all can turn on? So that has to be, the reliability has to be built in, and the repeatability. These are again beyond CIA paradigm, which we need to have a look at it. There is again challenges around internet and IP. Historically, for joining heterogeneous network, we needed internet and IP. And when IP, when we use, so typically, by now, I'm sure Professor Nandi has discussed a lot about 6LoWPAN and how the communication happens in case of IoT network. So when it is an all IP network, the weakness that are there in case of IP network, traditional IP network, again, also inherit. Okay. There are other challenges like, for example, RFID tags, which are sometimes devices or sometimes they are host. All that I think I won't go into that. So some of the challenges what we see in a day-to-day life in case of IoT environment, when an attacker actually tries to create problem, devices may not be reachable. So you'll find that most of the time some devices are not connected. Devices, that means you cannot monitor them continuously. Similarly, devices can be lost and stolen. An adversary can actually physically take a position of a device, and that can lead to a bad situation. One can analyze like what all data is stored, what is the process in it, or what are the mechanism in it. The third thing is that the devices many times doesn't have a crypto engine. That means you cannot implement good cryptographic algorithm. And many times when it has crypto engine, it is a very primitive crypto algorithm that is implemented. Okay, devices have finite life. That means the credential many times these field deployable devices, once you deploy it on field, you may not have the scope to change the credential. Okay, or some of the credential maybe it has a certain life which is tied to its lifetime. Devices are very transportable. Actually, one can easily carry it inside pocket or a small bag or whatever. So it will cross your organizational border. Traditional IT infrastructure normally doesn't cross your organizational border, but IoT does. And many times these are part of your BYOD, bring your own device ecosystem. So that also poses its own risk. Also, the devices needs to be recognized by multiple readers. That means what data, the data that is sensed by these devices might be read by multiple users. So what are the security works that are done in the Internet of Things arena? In case of assurance, we try to do a risk analysis, what all attacks that can happen on a device. Also, a common practice is to have a device in the risk analysis. I mean, of course, it is not only about analyzing what all attacks that are possible, but what all are the possibilities an adversary can do. Let's say if we lose the control of the device, what all that can happen, or if the adversary has a portion of data, what can happen. Also what we try to do is to analyze the device. That means we try to see for ourselves that what it contains, try to debug the application that is inside the device, or try to figure out the communication channel and see whether the systems are secure or not. Crypto capability and export analysis. We look at like if we are transmitting very high value data, whether we have enough crypto capability. For example, RFID tags doesn't have much of a crypto capability, and at least for another few years that is not going to happen. Right. So what are the objectives? The security objectives we identify. We try to do a privacy protection. That means the data that is there, that should remain always private, or it should not be revealed to the outside world. We do an identity protection. That means where from the data is generated, we try to keep it secret so that no one knows from where the data has been generated. If attacker knows that data has been generated in this from that particular area, they will try to plant some malicious device in that area and try to feed wrong data, or maybe try to take the physical control of the node in that area, or at least drain out the power of that node and you may not get any data from it. Then traffic analysis protection. We need to provide a traffic analysis protection in the terms of like even if the traffic is accessible by certain individual or certain bad element, they should not be able to figure out like what I'm sending. So that is traffic analysis protection. And then identity and identifier management. This is another challenging area in case of security in IoT. That means the end user of the IoT system, or even it can be another physical device which are accessing or which are interchanging messages in an IoT network, there should be a clear identity that has to be established, and identifier also has to be separate. Now let us come back to the original stack where we started, the security IoT architecture, that is information technology plus operational technology. So all of that has became a service model today. And what are the security components that are built around it? So we have physical, we think about physical security, that is security of the nodes, so that nobody can access those nodes or at least steal those nodes or physically harm those nodes. Device level security or anti-tampering, that if some node, somebody tries to temper some nodes, it is better that the node gets destroyed rather than getting it tempered. So we try to deploy anti-tampering or tamper-proof node. Then we have an end-to-end data encryption policy. What is an end-to-end data encryption? That means from the data generated to the receiver, there is a key exchange, and the data that is transmitted is encrypted. The way it happens in WhatsApp communication, that from your phone to the recipient's phone, there is a key exchange, and then the data is encrypted. So even WhatsApp themselves doesn't know what data you are sending. So that's called end-to-end encryption. Network and perimeter security, just like the traditional IT infrastructure, you need to have like network and perimeter based security in case of IoT network. And then cloud-based protection, cloud-based threat analysis and protection for your IoT services. So till now, this is what the model is that is followed in case of protecting the IoT ecosystem. Just okay. So how the IoT and OT are inherently different. Sorry, IT and operational technology. In case of IT, the connectivity is any to any. That means any host can communicate with any other host. In case of operational technology, connectivity is normally hierarchical in nature. So if one host wants to communicate, possibly it needs to contact its higher level host, which will eventually send it to more higher level, and then eventually at some point it will get connected. The network posture in case of traditional IT environment is highest priority is given to the confidentiality, followed by integrity and availability. In case of an operational technology, the highest importance is given to availability and then confidentiality. That is, it is reverse, it is AIC. So what are the security solution in case of IT is cyber security, data protection, etc. In case of operational technology, control, safety are also important. In case of IT, let's say, God forbid, if our laptop or our work desktop gets affected, what we do is we first try to quarantine. That means we try to remove it from the network. In case of operational technology, it is simply sometimes not possible because the operations are non-stop and mission critical. So never stop, even if it is breached. So we need to have enough resilience built in inside the network that even if some of my nodes are compromised, I should still be able to operate. Number of miserable track records are continuing, but one lucky thing is that most of these are related to consumer IoT. Testing or rather compromising industrial IoT is a bit trickier, but then We have brownfield deployments in the form of heterogeneous systems from multiple vendors with multiple operating systems and multiple different types. Okay. So to have an IoT deployment completely secure, what all things we should look at? If you remember, that was our third agenda in the meeting. So we have discussed the heads around IoT, the issues and challenges, and now we'll be discussing what will we do to keep the environment secure. So there is a project called OWASP. What is that? Stands for Open Source Foundation for Application Security. Traditionally, it was designed for web applications. That means when you design internet-facing applications, what all security measures that needs to be taken care of. So this organization publishes top 10 security threats and their possible countermeasures. Now, fortunately, OWASP has started an IoT top 10. They call it as a OWASP IoT project. That means what are the top 10 security threats that are there. So what it contains? Basically an overall security effort where it talks about the attack surface. That means what are the devices that can be compromised, the list of vulnerabilities, and what can be provided. Then it also gives guidance for developers. If you are developing an IoT based application, what all you need to keep in mind. IoT specific security principles and IoT framework assessments. All of provides. This is a screenshot of OWASP IoT top 10 of the year 2014. So every alternate year they actually updates that. If you look at what are the security threats at that time, it was there. Many of the IoT devices is a web interface. That part is not secure. Then insufficient authentication and authorization. That means when IoT devices are designed, the due emphasis is not given and authorization problems. Insecure network services. Many times IoT deployed in insecure network, and then lack of transport encryption. For example, all of us know that we have encryption in the form of TLS. Many times these are not available in case of IoT environment. There are concerns. There are insecure cloud when devices transmit or receive data from cloud or talks to cloud. Many times the interface is not secured. Insecure mobile interface, insufficient security configuration, insecure software firmware. So of that, so there are like listed. Now their description is given and what are the recommendation. There are links are available. So you can refer to OWASP top 10. This was for the year 2014. If you look at the latest one that is published in 2018, and another one will be in the later part of 2020. I'm not sure due to pandemic whether it gets affected or not, but I think it will come out. You see now the list has changed. Okay, so the priorities has changed. If you look at now, guessable or hard-coded password, insecure ecosystem interface, lack of secure mechanism. So now that is so what does that mean? That IoT threats are evolving or they are changing, and that is why you need to have a constant vigilance around IoT ecosystem and what are the threats and what are the attacks that are happening in today's world. So before I conclude, I will leave about 10 to 15 minutes for any question and answer session. That what are the principles that are there in IoT security you should follow? That you should assume a hostile edge. That means from the gateway level, you always consider that they are hostile. That means there can be adversary there. Test for scale. Look at whether the IoT system is highly scalable or not. There is the way Internet of Things are there. There is an Internet of lies. That means there are a lot of false information on the internet. Try to take care of that. That might actually spoil your IoT ecosystem. For example, it may be you are developing an application which needs weather data, and if you get the weather data from an unreliable source, your whole system will be affected. There is an exploit autonomy, similarly isolation, uniformity, encryption, tricky encryption system, etc. Then one important thing is system hardening. By default, when we buy a system off the shelf, many times they are not hardened. That means they are not properly configured, etc. So that also might create issues. There are limitations of what you can. There are life cycle supports, and always plan for the worst. That means if the worst happens, what options you have. Many times when you do an aggregation of data across multiple devices, they are unpredictable or unreliable. Plan for that as well. Always think about the long haul. That means long term, what is the impact. Also target the attackers always target the weakness that is there in your system. Be careful about your weakness. There can be transitive ownership. That means you own something which you give it to someone else and they give it to someone else. So there can be this transitive ownership. Be careful about it. And you should have N-is-to-N authentication mechanism. That means as many devices are there, authentications are there, that many authentications should be there. So the assessment also needs to be done. Means what does it is that you should have a proper checklist in case of a prototypical IoT deployment to do. For example, I'm showing you that a mobile based application which can actually request from a vending machine a cup of tea or coffee. So what all that will go in between? The mobile phone will possibly talk to some server on the cloud, which will send some notification to a gateway, which will eventually tell the a vending machine to provide or to get activated to release a cup of tea or coffee. Now, what all messages that might pass through in the whole cycle that needs to be checklisted and benchmarked so that you can figure out like what all that can go on. So what are the considerations at the edge level? That means at the gateway level in an system. We need to look at whether our communications is encrypted or not. If not, we should. So there are two types of data security. One is that data security of data at rest. That means where whatever data you stored, it should be encrypted, and whatever data you transmit, that also has to be encrypted. How is logging performed? That means all activities that are done. So whether it is done properly, is there an updating mechanism? Can you update the application, the software, etc.? Whether there are any default password, you should always change it, because if there is default password, I can look at the website that what are the default password of that device and try to gain control of that device. And what are the offline security features that are there? If there is a vending machine, whether somebody can open the screw that is beyond the control of IT based security mechanism, and whether the transitive ownership. Now there are other considerations, for example, whether the encryption is, I should have an end-to-end encryption in between, like encryption should not be interrupted. Storage, whether it is encrypted, whether any anomaly process, whether login are there or not. Similarly, cloud, check that whenever you are connecting is whether there is a secure web interface or not. You should never transmit data in plain text. Is there any data classifications? Whether there is a security event reporting, any third-party component that are to be updated or tracked, whether there is a audit capability or not. What is an audit capability? That later on I should be able to match all that has happened. Whether there is an interface segregation, whether there is multi-factor authentication allowed or not. Multi-factor authentication means you should not rely only on your username and password. You should have more to it. Okay, and there are other security considerations that are there in case of mobile security consideration, like you have capped for theft or loss of a device. Does your authentication degrade? Whether local storage has been done securely, whether there are audit trails, and whether there is authentication for. So some final thoughts is that privacy is a IoT world when large amount of big data and we are looking at when big data. Regulations are still evolving. Many countries are yet to come up with guidelines. Consumer might eschew their safety, but business should not, or business cannot actually. So in case of industrial IoT, we need to be very careful. And in case of security, in case of IoT, security can be a differentiator, whether you have proper security mechanism or not. So with that, I'll conclude. I have about 10 minutes. If you have any queries, I'll be happy to answer.
Thank you, sir. So there is one question from Dr. Yeah. Sir, they are asking, like, there is one query. What are the environmental attacks?
Okay, I will come to that. Okay. Just give me a moment.
Yeah, sure, sir.
Let me open the Q&A and let me check. Okay, what is the environmental effect? As I mentioned earlier, that you deploy an IoT ecosystem or IoT service in a location, you are not aware about, or when you have deployed it, at that time there was no problem as such, but then suddenly somebody erects a wall or somebody erects a building in between. You lose the line of sight. Your communication gets disrupted. This may be intentional or may not be intentional. In many cases it is not intentional, but then your communication gets disrupted. Similarly, imagine that you field deploy some agricultural IoT equipment, right? And one farmer goes and is not aware about anything, and he plows out all your sensors. So those are environmental, where you have less of a control. Okay. Or think about something like somebody sprays water on your electronics equipment. Okay. So or let's say because of a thunderstorm, things gets affected. Okay. So those are environmental. Okay, let me check further, is there any platform or simulator to do IoT security attack framework? Well, the answer is no. There is no specific, attack framework for IoT, but the existing framework, as you know, that this is nothing but yet another network. Existing framework can be used. Only thing is that protocols like COAP, MQTT, if you want to see their vulnerability, there are specific tools available for those protocols. But if you say IoT as such, it is variety. So you do not have one suit which serves all the purpose. Okay. Any other question? Let me check if there is. Oh, I can see that may not be. So that is not for my session. Something like blob transfer. So I do not see any other question.
Sir,
okay, so a couple of more questions. Yeah, one more question.
Yes,
How can we say that a driverless car is secure and is ready for use? I don't know. It depends. A driverless car, of course, it is considered as a part of an IoT ecosystem. Now that depends on a lot of factors, like what are the softwares that has been used, whether they have been tested, security tested or not. But I'm sure, like if Tesla has manufactured it, I'm sure they have done enough of testing on it. Google will do enough of testing on it. But if it is if a driverless car is prepared or put together by university student, there may not be enough testing in it. Now, having said that, there can be a vulnerability in Tesla also. But good part is that if a vulnerability is discovered in Tesla, it will be the responsibility of Tesla to fix that vulnerability, right? And if it is prepared, if a driverless car is prepared in my in the garage next to my house, then I don't know, like whether there will be security vulnerability or not. But yeah, for all enterprise level product, there will be some support available. Does that answer your question? I hope you got your answer. Any other question anybody has?
So is there any IoT attack in India ever?
Oh, there are many. There are plenty. So there are multiple types. Like one was on the IoT devices. Specific, I think it is the Karnataka SCADA, power SCADA system. Then there was one IoT heavy, or rather very large scale IoT attacks using CCTV cameras around NCR region, that is Delhi region. There were attacks in the control system of the Indian Railways. So name anything. Just Google it, like attack on Indian IoT infrastructure. There are like plenty, or at least one attack you will see in a week. So yeah, and then I can tell you the number of attacks has gone up with the pandemic in place, because many of the bad guys are free at home, so they are having their good time in attacking relentlessly. Any other question I'm missing?
So there is a question, sir. Tell the tools for checking the vulnerability in COAP or MQTT, which is more secure.
COAP and MQTT has its what is called on different purpose. So there may not be one single tool which can address both. There is one tool called NetBurner, which actually can look at vulnerability of COAP. There are many other tools which are available on GitHub, which are open source, like Autoxp, then SmartBR, many others. So what you need to do is that just search for it, download, see its capability, and check for yourself which one which one you want. Again, it depends on what kind of application you are building. If it is a data-centric application, the vulnerability assessment is different. If it is a compute-centric and application, again it will be different. So it depends on like how your topology is, how you are building the system. So there is no one meal which serves all the purpose. Okay, it's pretty customized, and the number of tools are very large in number, maybe a few dozens at least. Any other question?
No, sir, I think so. May I request any participant if they want to put forward the query? You can please raise your hand. We will unmute you.
Sir, there is one more question, sir. So using ML technique, how to detect DDoS attack in IoT security?
Again, it depends on what kind of ML you want to use. See, the challenge of DDoS attack is that it is an indiscriminate attack, and there is no signature like which can tell whether it is a fake, request or a genuine request. Now, in such situation, when no such signature is available, what I can always rely on is that I look at the volume. Say, suddenly I see like 1,000 requests per second, which should not be real, right? I'm not Amazon that I should expect 1,000 requests per second, or I never do a business or like I do not have any user in some countries in Africa like Uganda. So like why should I have requests coming from Uganda? So those kind of anomalies you can try to detect. You can have a data set and you can use appropriate machine learning technique, whatever that suits you, maybe deep learning or and then figure out like given a situation whether there is any attack or not. Okay. So the machine learning technique is totally up to your machine learning knowledge and your suitability. The data can be from IoT paradigm. I hope that answers your question. Any other question?
Yes, Mr. Somyaditya Roy. So we have unmuted you. So you can please put your query.
Thank you, ma'am. Good afternoon, sir. Am I audible?
Yes, you are audible.
Okay. Sir, actually, my question is more from the security concern that nowadays we are so much exposed in online due to this pandemic. So is there any way to identify that whether anyone from the remote location are accessing my webcam or some of the peripherals which is attached to my laptop or desktop using some tools like Wireshark or something like that, which is the packet analyzer tool? Because when we are online, yes, I'm here. Hello.
Yeah, I could not hear the last part of your question.
Hello. Yeah. Actually, I just want to ask you that whether is there any way to identify that whether anyone is accessing my webcam or some the other peripherals which are attached to my desktop or laptop from the remote location without my consent or something like that, because we are so much exposed these days to online. Suppose I'm working on my laptop and someone is hacking my webcam and watching me. So how to identify that using any of the tools like say Wireshark or something?
You don't
like
require
that?
tools.
Okay.
If you know how to look at processes, you look at processes. Any process, whether it is accessing webcam or not. So that will do. And if you want to remain safe, of course, there are, you always may not have to build a pan which works in space, but you can always use a pencil. You can put a sticker on your, webcam in front of your webcam.
Yes, sir. Yes,
just
sir. I actually
the webcam
did
or fold a piece of paper. And,
yes, I
place it
actually
there.
doing that.
So that works. See,
Okay.
you cannot continually monitor your laptop, right? You have other works to do.
Exactly. Okay, sir. Thank you. It's a very good session, and thank you for your for this session. Thanks a lot.
Thank you.
Yeah, and thank you, ma'am.
If there is no other
Yes,
question, then thank you very much for attending my session so patiently. And hopefully someday in some place we will see each other in person. So things are in virtual as of now. Yeah, but we'll meet someday.
Sir, there is a last query from Mr. Lova Raju K. Can we unmute him, sir?
Sure.
Yes, Mr. Love Raju.
Yes, madam. Yes, madam. Thank you, madam.
Yes, sir.
Sir, thank you for your unstoppable speech regarding clouds and cloud security for IoT. Hello, sir.
Yeah, I can hear you. Go ahead.
Sir, I have one doubt, sir, regarding which types of clouds are used in IoT for agriculture applications.
Which type of cloud are suitable for IoT?
Yes, are used in IoT for agriculture applications.
So almost all large cloud service provider has an IoT offering. Okay. For example, AWS has something called IoT Core. Okay. So Google has something called Google IoT.
Yes, sir.
Similarly, Microsoft Azure also has an IoT offering. So you need to choose. It is totally up to you. All of them are secure, but if you do not implement the security mechanism, your application will remain insecure. They provide all security mechanisms which are there.
Okay, sir. Okay, sir.
Okay.
Okay, sir. Thank you. Thank you, sir.
All right. Thank you very much.
Thank you, sir. I think so. All the queries are already been addressed, sir. So, sir, can we end the session, sir?
Thank you very much.
Yeah. Thank you, sir, for such an informative talk. On behalf of E&ICT Academy, we thank you for the same. Thank you, sir.
So,
Dear participants,
email ID, if anybody wants to reach me, can reach on this email ID. Thank you once again. See you.
thank you, sir. Dear participant, there is a small announcement again. Today we are having the MCQ from 2 to 2:15. I request you all to please connect us by 2 o'clock and please complete and submit your query before 2:15. So with this, we are closing the day 9 session. Thank you all.
अब ये BHEL, HL सबका भला हो गया मेरा लेक्चर से